Dr. Pawarji and my colleague Dr. Sachin Bakre, and dear friends. I am really excited and delighted to be here for giving a talk on subject related to earthquake engineering. So first of all, I thank SND for calling us to be with you. I am quite amazed to see the infrastructure of the college. It is really very good, and the cohesiveness of these departments. Yesterday evening, Professor Pawar and Dr. Ansari, we were together, and myself and Dr. Sachin Bakre, we were discussing that if the faculties are cohesive in any institution, it is surely going to reach a greater heights. Okay, so in that way, the department and I think the college is doing very good. Along with this, regarding this ATAL FDP, so I have also conducted ATAL FDP and some similar projects funded by DST and other departments. Overall, if you see, Government of India is trying to promote a research culture among the teachers and students. Now, if you see the older older pattern of engineering education, it was primarily based on classroom teaching. The research component was very less, and initially it was understood that research institutions like IITs, they were the primary research institute, and then comes the NIT and the other colleges, they will go with the teaching aspects. But if you see in last 15-20 years, the technology is changing so fast that if you are just sticking to your course book, and obviously changing a course book, it takes 10 years, 15 years. So majority of the student will be not introduced to the recent technologies. And that's why all over the world this change has come, that in undergraduate studies, they are including research component. And that is very important. Research component also provides us out-of-box thinking. So when just reading the line and just writing it on the answer sheet, it is not going to fetch our recent world's need. And all of us, whether we are in teaching profession, whether we are a student or whether we are in industry, now it is very important for all of us to see the innovations in that. And for that matter, yesterday I was talking to Dr. Ansari that the institute should have an innovation hub. Like here, we have got 5 basic departments, and all the departments have got its own infrastructure, its own lab. But now you cannot isolate a civil engineering student away from the computers, because the primary requirement of student is now they should understand the computer, they should know the technology, how to implement it. Same thing is with mechanical engineer and other. So it is a need of our to develop innovation hub, where faculties from different department and students of different department, like one group which will have one student from computer science, one from civil engineering, mechanical engineering, and mechatronics and other branches. And then if they start thinking, obviously something new will come up. So that was one thing which I suggested that it can be done, and with such a cohesive group of faculties. The second aspect which I was telling is to promote higher education in students. So I am actually thankful to SND that in this area, such a nice engineering college and infrastructure you have developed, and that is actually helping the students and local people, and it is very creditable to you and the complete society. So you are doing a great job for this area. Now we have to promote the students, local students, to a global level, and for that, first platform is GATE. So GATE education, over and above our normal teaching, should be included. Okay, and then this research, when the students from this institution will start going in IITs and NITs and outside world, the visibility of the student college will also improve. Okay, so overall, the institute is doing good, the faculties are good, and there is no bounds which can stop the institute to grow. So my all the best, and thank you for calling me. Thank you very much.
Steel has got both very good, tensile strength as well as compressive strength. So when you compress it, it will try to come out. So it will break the concrete and it will come out of the concrete. Now, if you tie it here, what will happen? When it is trying to come out in this direction, there are two forces which is trying to restrict it. Okay. Now, if you confine it more properly, what will happen? All those bars will behave in an integrated way and it will not come out. Okay. And that is the confinement. And basically this confinement pattern, different confinement pattern, is making your brittle concrete ductile. Okay. So that's why if you see in modern design of reinforced concrete, that lot of emphasis is given on these stirrups to make it ductile. This ductility advantage, we are reducing force by 5 times smaller force. That is only possible if we make our structure ductile using this one. Now you see, this is the example of 2 columns which failed in earthquake. Now the first column, if you see, the spacing between stirrup is very large, and obviously due to that the concrete was not confined, and ultimately these concrete spurred out. Cracking happened and it came out. Whereas if you see this column, if you see the total deformation, it is much larger here. It has bent at least by half a meter, and still whole concrete is there. This is due to this closely spaced stirrup and making it ductile. So this is the this is how we can make a non-ductile member ductile. Okay. Now let's understand another methodology for earthquake, principle of earthquake resistant design. Okay. This is a chain analogy. Okay. Chain analogy means, let us take a chain. Okay. Chain is made up of number of links. Let us say 10-15 links are there. Each link can fail. Let us say each link is brittle link and it can fail at 100 kilonewton. If you apply, each link is having 100 kilonewton capacity. Okay. Now, if you keep applying load, if you keep pulling it, what will happen? As soon as it reaches 100 kilonewton, one of the link is going to fail. And since that all the links are brittle, so it will be suddenly failing and the chain will be non-usable. Now, out of that 10, 15 or 100 links, let's take out one link and design it for 95 kilonewton and make it ductile. Only one link, what we are doing, we are making one link ductile, the rest of the link is as it is. And now if I am applying force, 10, 20, 30, 40, as it reaches 90, 95, what will happen? This, others are having capacity of 100 Newton. This, the ductile link will start yielding at 95 kilonewton. And since only one link, that link is ductile, the whole chain will behave as ductile. Because we have allowed that one. The same principle we are going to use in earthquake resistant design. We are deliberately making few of the failure modes as ductile modes, and other modes we are designing it for little higher force, so that even the shear is happening, it will not fail in shear. Okay. And this all thing is ensured by our code. The code for ductile detailing for reinforced concrete is 13920. Now you see, this is also interesting for all of us to understand. This is hinge formation. Like when earthquake comes, as I told you, if we have not designed for actual earthquake, we have designed for R times lesser, what will happen? There will be cracking and energy will get dissipated. Now here, if you see, these are the two structures. This and here we are allowing the damage to happen in column. Okay, and in this one we have made column stronger, and we are allowing damage to happen only in beam. Okay, and if this lateral load happens, what will happen if column failure is happening? This will be a catastrophic failure, the whole floor will come down. If you see this figure, 1, 2, almost 5 floors are there one over the other. That is like a pancake failure. So एक column निकलेगा, उसके ऊपर से सारी building की floor गिर जाएगी. And this is happening by just formation of 8 hinges. 8 hinges जब बने हैं तो कितनी energy dissipate करेगा? इसकी जगह पे if you see here, we have got 30 hinges almost forming in beam. All the energy will be dissipated, जो भी earthquake है, and still your structure, after so much of deformation, it will survive. The people will not die. So this principle we are going to use in making our building earthquake resistant. Okay. So I will quickly go with some of the points here. Okay. These are the different codes. And if you see this ductile design and detailing in Indian code, now our Indian code is at par with all the American codes or European codes, so they have improved. Okay. Now you see, this is stress strain curve of different material. Okay. Now in lab, when we do material testing, so when we are testing these bars in tension, we expect that strain elongation should be around 14 to 20%. Okay. Now 14 to 20% elongation is there. If you see mild steel, this strain is largest, and if you go for higher strength of steel, due to increase in carbon percentage, this elongation will be lesser. It will keep on reducing. Okay. There is most ductile and then the ductility reduces. Now, if you see earthquake, the maximum strain what we are going to get is only 5%. Only 5% required. And in lab, we are testing and we are telling that it should be at least 14% to 20%. Okay. The reason behind that is when we are considering it in lab test, it is monotonic in one direction. But when we are talking of earthquake, it is cyclic in both directions. So if a material can sustain monotonic 14%, then only it can sustain cyclic by 5%. So that's why lab test is very important. So for this steel, there are some important points like in different zones, we should consider the ductile detailing code. What is the seismic zone? What is it? यहाँ पर 2 है. Okay. Now this code is getting revised, and probably the draft code is there, so it is going to become 3 this area. So if you see for different seismic zones, these are the design criteria. The aspects which we understand, which we should understand here, that whatever I discussed, that was the basic principle. Now let us see how we are going to implement in our realistic design. First thing is, if you see the proof strength and this characteristic strength. So for steel, what we do, if the yield point is not very clear, we take 0.2% proof strain and we draw it. Okay. Now, the point what we need to understand is we are talking of post-yield behavior of material. So, ductile behavior of material. Now, if it is yielding, okay, what should be the difference between maximum yield point and the yield point? Code suggests that it should be 20%. Maximum is 20%. And similarly, maximum, the yield and the ultimate the maximum ultimate value, it should be 15%. Okay. So if you see, for building steel, there are very stringent criteria. So majority of steel manufacturing companies, those who are using recycled steel, we have to be very careful because many times you will not find that it is going to comply with this one. Even though if we are, let us say, if we are saying that it is for Fe 500, so it is quite possible that its yield strength comes to be 700, but that is not allowed. Okay, because then this whole concept of ductile detailing will be lost. So it is also कि भाई अगर 500 का यूज करना है स्टील और हम 700 का यूज कर रहे हैं तो बेटर है, ये रॉन्ग कॉन्सेप्ट है. जिसके लिए डिजाइन किया है वही होना चाहिए हमारा. दूसरा जो डक्टिलिटी और ब्रिटल फेलियर है, तो रिसाइकल्ड स्टील में वी हैव टू बी डबली श्योर. उसकी मल्टीपल, कम से कम जो नॉर्मल टेस्टिंग है उसका 1.5 टाइम्स में नंबर्स टेस्टिंग करना चाहिए. नाउ अदर एस्पेक्ट, और ये है इंटरमीडिएट शेयर वॉल. तो पहले तो इन तीनों का अलग अलग क्राइटेरिया कैटेगराइजेशन दिया है, और कैटेगराइजेशन करने के बाद तीनों के लिए अलग अलग मेथड्स ऑफ डिजाइन कोड ने प्रपोज किया है. ये बार कैसे होना चाहिए. अभी एक और बड़ा इंटरेस्टिंग, मोस्ट ऑफ द टाइम यू विल सी ये वाला बार, हॉरिजॉन्टल बार बाहर रहना चाहिए या वर्टिकल वाला बार बाहर रहना चाहिए. तो ये डिबेट कई लोगों के पास में है. ये ओवरऑल कंफाइनमेंट के लिए इसको रिंग एक्ट करना है. शेयर वॉल के लिए भी जो साइजेस थिकनेस है वो बार पर डिपेंडेंट है. अगर 12 mm का कर रहे हैं तो मिनिमम साइज 150 है शेयर वॉल का थिकनेस. अगर 16 कर रहे हैं तो 175 है. और अगर इन जनरल यू विल फाइंड 200 mm वॉल देना है 2 लेयर में रीइंफोर्समेंट डाल करके. Overall, if you see, there are a lot of information. These information, this is for coupling beam. ये दो shear wall है, उनके बीच के जो beams है ये coupling beam है. coupling beam के behavior के लिए कोड ने गाइडलाइन दिया है कि coupling beam हम कैसे डिजाइन करेंगे.
Then we'll move ahead with AICTE design philosophy for the structural design. Then role of damping, followed by seismic protection of structures. And what are the two methodologies through which you can protect the structures for seismic forces. Within that we'll be going in depth for the passive control measures of the structures. Okay. Then active control measures, some introduction, semi-active, hybrid control, some introduction, and then finally few slides on base isolation. Okay. And followed by the 4 to 5 case studies in which various structures has been modeled and equipped with dampers to enhance their structural response. So there will be around 3 to 4 case studies, and then ultimately we'll be concluding with the presentation, like what is the final conclusions for this work. The work which I am going to present here is carried out by my research students, then MTech students, then a few work of mine where I was doing PhD, and one work is there from my MTech. And on that work, which is based on passive control measures, we have recently received a research project from DSIR, that is the Department of Scientific and Industrial Research. So that portion is also there. Okay, so let's go ahead. I will quickly browse through these slides. What causes an earthquake? So this is a small presentation. So we have a representation of the same. We have two different plates, okay, divided by a weak section which is called as fault. And these two plates try to move relative to each other in opposite direction. And then there is a stage which is shown in stage B, that is strained one, and then they suddenly slips. So that is called as elastic strain buildup, and the theory behind this is called as elastic rebound theory. Okay, and based on that we assume that the earthquake source is going to happen at the faults, and huge energy is released during this movement. Now there are around 7 natural plates, 13 natural plates and 7 sub plates, smaller plates, through which the movement is still going. So you can see here, this is the diagram which is taken from Demetz et al. In published in 1990. So this data is quite old, but you can see some arrows has been marked over here. Okay, these are all plate boundaries. So this is not this is map of world. So we have Indian plate over here. Okay, then Australian plate, South America, North America, and all the plates at the boundaries you can see arrows. So here, taking an example of one arrow, you can see here 103 is written over there. So what does that mean? Arrow moving away from each other is relative motion in mm per year. So these plates are moving away from each other with a velocity or with a rate of 103 mm per year. Okay, and same we see over here. Okay, Indian continent you can see here. So we have 48 mm per year. So that is the location of Himalayas. So two plates are colliding and they are still coming near to each other, and that's why there is formation of Himalayas. Okay, Himalayan mountain ranges are due to that formation. Okay. Now, giving enough evidence of this theory, that is elastic rebound theory, you can see like this is the dark. They are all dark spots, and most of this is India. Okay, and most of the dark spots are along the plate boundaries. These are the plate boundaries, and this map may not be matching with that. So all the dots, there exists a particular case where the zeta t, that is the diameter, 2 to 4% also gives you reduction. Okay, but when you want maximum reduction, you have to go for the optimum parameters, right? So these are the optimum parameters. Then you can see like observations in TMD. So TMDs are very effective in vibration control. There exist design parameters for all combinations of loadings and parameters minimized. Then explicit expressions you can develop. Like a damped system, it's very difficult to go for a closed form solution. So you have to go for numerical searching technique to find out the dampers. So through that you can generate expressions by curve fitting technique, and you can go for the expressions which will be required for the optimum parameters. So that is also possible. Then example of tune mass damper. So you might be aware of Statue of Unity, that is the statue of Sardar Vallabhbhai Patel in Gujarat. So we have these levels over here. So first level is viewing gallery, this is viewing platform, then this is intermediate levels for transfer, and then this is mezzanine floor and statue base. So we have a museum over here of all the artifacts kept over there, and then this is the statue base, and lift start from here, which take you up to the viewing gallery. Okay, so you can see the statue is built to withstand of up to 180 kilometers per hour, that is 110 miles per hour of wind, and earthquake measuring 6.5 on Richter scale, which are at the depth of 10 km and within a radius of 12 km of the statue. So this is aided by the use of two 250-ton tune mass dampers, which ensure maximum stability. So the dampers are kept over here. These are the concrete walls, and the concrete walls are made so thick that they consist of around 250 each, 250 ton each. Aided by 250 each. And this is concrete structure, left one, and the right one is the steel outside portion of the statue. So these are other examples. So you might be aware of Taipei 101. So that is equipped with tune mass damper. Then these are various examples all over the world where tune mass damper has been used. Now moving on to multiple tune mass dampers. So the issue with tune mass damper is that it should be tuned to the fundamental frequency of the main system. Then only it works. Okay, and suppose you have some mistuning, then it can reversely affect the response of the structure. The response of the structure could increase after using the TMD. So to avoid that, what we can do is we can go for multiple tune mass damper. Multiple tune mass damper, what they do is they damp the response of the system within a band of frequencies. So if your structure is having a frequency of say 10 Hertz, and then you can design a MTMD within a range of 5 to 15 Hertz. Okay, so all the frequencies that would occur in the range of 5 to 10 Hertz will be damped by the MTMD. Okay, so that is the use of MTMD over TMD, and there is this is how it looks like. There are various single degree of freedom systems acting as each TMD, and since these are TMDs in multiple numbers, they are called as multiple tune mass damper. And these are the parameters of the multiple tune mass damper. Then you can see here, if n is equal to 1, that is it's a tune mass damper, single TMD is used. So this is again peak of R for all various cases, and for each zeta of the system, that is damping in the system, this is for 0%, that is again 0, that is again 0. This is for frequency ratio 1, zeta equal to 5%, 5%, 5%. So if you go for 21 multiple tune mass dampers, the response reduces much higher as compared to this blue line. But forget this zone. So if your structure is in this zone, you can go for 21. Then here entire response is reduced to a very flattened curve. Then same are the observations for zeta equal to 5%, right? And beta is the frequency bandwidth, so that is 0.2. So that is the use of multiple tune mass dampers. An example of MTMD, this is one of the publications. So I forgot to write down the details of the publication. They have used the MTMD in the box girder of the metro. Okay, somewhere in Japan, if I am not wrong. So these are the tracks, and when there used to be a single train running on the box, it was seen like this structure was vibrating a lot, the deck slab. That's why they put multiple TMDs attached to the deck slab, and then it was observed that it reduced the responses of the system. Then next device is tuned liquid damper. So tuned liquid damper is essentially consists of a water tank which is placed on the top of the structure. So in Bhuj earthquake, it has been observed that there was a building structure having a swimming pool at the top of the structure, but then that entire structure collapsed, okay, due to additional weight on the top of it, due to earthquake, so earthquake forces. But here tuned, it is not, that might have acted as a tuned, not tuned, but just liquid stored over there. So here you have to tune the liquid to the fundamental frequency, then only it will work. So if we have a proper designed tuned liquid damper with the size of the damper designed as per the requirement, and then the provision of baffle walls, okay, to collide with the structure, thereby reducing the increasing the damping by the sloshing effect of the water. So here you can see modeling, you can go for this paper. So this is the 13th World Conference on Earthquake Engineering. So modeling of the tuned liquid damper is provided in this paper. So it's quite complicated. It involves simultaneous solving the Navier-Stokes equation along with the Runge-Kutta method, second order. Okay, and then only you can reach for the responses of the structure. So these publications, that's why I avoided to put the equations here. So this is the reference to the paper where you can get details of tuned liquid damper. This is how it looks. So these are the baffle walls in between the tank. This is the structure, and this is the tuned liquid damper at the top. So these are the baffle walls. When the liquid moves here and there, So it collides with the baffle wall, and then there is a energy dissipation. So this is somewhere in San Francisco. Then viscous and viscoelastic dampers. So viscous dampers are very common. So you know the dampers provided on the door. So they are also viscous dampers only. So these are the dampers which are especially designed for increasing the damping in the main structure and reducing the response. So easy computational implementation. Easy means you just have to use one equation, that is C into U dot. Okay, so C is the damping coefficient and U dot is the velocity passing through the system. So that is only is required. So it's very simple in computational implementation. Then VEDs stands for viscoelastic dampers. So viscoelastic dampers means it has got damping, and in addition to that it has stiffness. So whereas viscous dampers only have viscosity in it, which depends on the velocity through the damper. Here we have stiffness as well as damping, both, and their modeling looks something like this. So here we just have a dashpot. Okay, it can be represented, this damper can be represented just by a dashpot, and we have the damping force FD, and here we have stiffness plus dashpot, and these provision of stiffness and dashpot, if they are in one single line or linear, so then it will be a liquid viscoelastic element or very flexible element. If you have a solid viscoelastic element used, so they will be parallel to each other. Okay, and for this you need to go for Kelvin model, Maxwell model, and the one where we have they in parallel placed, then you have to go for Maxwell's model, Kelvin's model. This is Maxwell, that is Kelvin. So how VEDs are used, that is viscoelastic dampers are important for industrial structures like petrochemical plants. Why they are important there? Because there are various equipments, loops of the piping and all the arrangements which has different natural frequencies of their own, and they are placed on the main system, okay, which is the walls of the buildings or somewhere like that, or floors. So each of the systems vibrates separately, okay, control. Okay, so they work in both the direction, for both the input forces. So our general design philosophy is something like this. For minor shaking, there will be no damage to the structural members, but minor damage to non-structural elements is permitted. Then second is moderate shaking. During moderate shaking, there will be major damage to non-structural elements, but structural elements like beams can be get damaged, but they will not collapse. Not enough plastic hinge will form for the collapse of the structure. But in strong shaking, you will get enough plastic hinges, but our assumption is that the structure should not collide and it should structure should not collapse, and it should give enough time or ample time for the occupants to vacate the structure, so that there should not be any life threatening damage, right? Then how to deal with this? You cannot reduce the earthquake force, you cannot reduce the wind force, so you have only one thing in hand, that is called as damping of the structure. So those who have learned the topic of structural dynamics, so they might be aware of the role of damping in reducing the vibrations of the structure. So reduction in the response will be achieved by enhancing the damping of the structure by the use of these energy dissipating devices. So just one slide on damping to get an idea. So first is what we understand by damping in structure. So that is reduction of intensity with time or spatial propagation, that is vibration energy transformed thermal energy by radiating to outside, right? And it can be also called as seas of vibration with time, and reduction of wind induced or earthquake induced vibration. So this plot you can go through, and for a system with zero damping, these peaks will remain at the same position and it will keep on vibrating like that. If we have a structure in vacuum and it is not acted upon by any other external force, not even damping, it's a undamped structure, so it will vibrate something like this continuously, right? And as soon as you introduce damping in the structure, which every other structure we have, which we see around us, so you can see it is diminishing, right? The structure response will reduce as the time of vibration increases. So you can easily find out the damping by logarithmic decrement method, and here the zeta term is the damping coefficient, right? And by taking the log of this peak and this peak to adjacent peak and equating to logarithmic decrement, you can find out the damping in the structure. Okay. Now, what are the factors that include damping? So number one is relative displacement between molecules of the material, then material damping, cracks, and all such mechanisms together will be accounting for the coefficient zeta, right? Then here onwards our main topic starts. So you have to protect the structure from seismic effects or wind effects. So you have two methods you can go for. The first one is either strengthening measures, in which what we are going to do is we are going to design the building for seismic resistance based design, and going for this technique will lead you structure having larger column sizes, larger beam sizes. Okay, everything will be large enough to take care of the earthquake forces acting on the structure, maybe earthquake or wind, and these are lateral forces as you are already aware. And what is going to happen in this case, that is strengthening measure, is that you are designing the structure for something which you do not know whether it would occur in the lifespan of the structure or not. What we do is we are assuming that there is going to be such and such magnitude earthquake in the lifetime of the structure, and you are strengthening it to remain elastic throughout the life, okay, even after it is attacked by upon or acted upon by the earthquake forces. So that's why strengthening measures are not recommended, may not be or not feasible, because it gives you uneconomical structure. So what you can go for is the response control based design, in which what we primarily do is we use any of the control methods like passive control, active control, semi-active control, and hybrid control. And what we principally do in that is we use the energy dissipating devices which are either following any of these technologies, either passive, active, semi-active, or hybrid. And these devices are also called as supplemental devices. Why supplemental devices? Because they are added additionally or supplemented to the main structural damping, and it enhances the damping capacity of the structure. Okay, so whatever earthquake input energy is transferred to the structure, that energy is absorbed using these devices, okay, through role of damping in it. So we are trying to increase the damping in the structure. So best example what you can give is or structural fuses, electrical fuses. You are aware of electrical fuse. So what is the use of electrical fuse? Whenever there is any immediate increase in the voltage, the electrical fuse goes away, right? So it blows away, and that thereby it reduces the damage to the appliances, electrical appliances. So same thing these devices do. So what they do is they work as structural fuses, and after any event of earthquake or maybe wind or cyclone, what you can do is these fuses will get damaged, or these devices will get damaged, and you can replace them with another devices, but they will safeguard the structure as a whole. So here what is the concept? That is the car collision analogy. You might be knowing like car is equipped with airbags, and what is the role of airbags? It is to save the occupant. So here also same concept is applied. So in earthquake our principal idea is we have to reduce the damage to the structure, and that's why we'll be going for energy dissipating devices, right? So starting with the passive control measures. So controls, these devices control the response of the structure by virtue of their motion. Okay, there is no additional power or any other arrangement made in the structure to reduce the responses. Okay, so this is a abstract technology, that means it was once ignored and then again it was adopted. So passive control devices which will be covered will be base isolators, then metallic dampers. So within metallic dampers we have triangular plate damper, H plate damper, and few more. So within that I will be covering only X plate damper. Then we have friction dampers, viscous and viscoelastic dampers, then tune mass dampers and multiple tune mass dampers. So one slide per passive control device I have added, so we'll just browse through it. Now first the control methodology. So this is the passive control devices. Now active control measures is, it involves computer simulated mechanisms. So what they usually do is, entire structure is equipped with lot of sensors, and as soon as wind or earthquake occurs and building vibrates, these sensors give measures the response in specific directions and submit it to the control devices. So these devices will be finding out like which portion is moving towards right, and then there are actuators placed in the structure so that they push the building in opposite direction. So it requires lot of very costly, and it requires large external power. So that is not the case with the passive devices. So passive devices does not require any external feedback. That is active control, and mostly applications of these kind of technologies are reported in the Western countries. Then also in vehicles and airplanes. So semi-active means we have requirement of same thing, so but it will be will be taking less external power. And hybrid means you combine any of the two technologies to reduce the response, and the resulting system will be the hybrid control. Okay, so let's go with the passive energy dissipating devices. So objective is clear: to reduce the seismic response of any structure by diminishing the energy, earthquake input energy, and to reduce the loads on the members. So these devices are incorporated in structures as braces, walls, sub-columns, or in various combinations of these configurations. So you can see the classification of these devices. So first one is the indirect energy dissipation, and second is the direct dissipation energy dissipation method. So within that you can see we have viscous and viscous fluid dampers and metallic dampers. So they are direct energy dissipation devices, and in indirect we have tuned mass damper, that is also called as TMD, tuned liquid damper, that is also called as TLD, and MTMD stands for multiple tuned mass damper. So we will have more than one damper to damp the energy. Now the bracketed term, you can see the case studies which are put together in this presentation are for the bracketed devices. First one is tuned mass damper, then the viscous fluid damper and metallic dampers. So then few videos are there for base isolation systems and working of viscous fluid dampers. Okay, so tuned mass dampers, these are linear systems. Linear systems means the damping is also linear and the system is also linear. So it is very easy, it has very easy computational implementation, and then it involves no complicated mechanism. So to solve for the equations is also easy, not very complicated, and energy dissipation occurs by virtue of the structural motion. And it has been successfully implemented all over the world for buildings, bridges and other civil and mechanical systems. So these are the TMD properties. So those who are from the dynamics background will be able to judge this, that this is a single degree of freedom system, okay, main system, and then it is added with the TMD system, making it 2 degree of freedom system. Okay, and the main system mass is ms, and the mass of TMD is mt. Okay, as denoted there. So CT will be CT is the damping in the tube mass in the TMD, and that damping could be same as that of the main system, or it could be higher. It depends which you choose. Then the purpose of this MT, CT and KT is that to reduce the vibration excess. So the one which is shown over here, that is the displacement, velocity or acceleration of the system, that will be reduced by putting this small system over the main system. So this small system will have a mass which will be around 5 to 10% of the mass of the main system. Okay, it cannot be more than that. You can provide more mass, but then that system will not be optimum. Okay, so suppose if you go for mass ratio 5 to 10%, that system will reduce the vibrations of the main system by around 30 to 40%, in few cases 50%. But then if you do not tune it with the main system, and if the mass is more, then it may not give you that much reduction. But reduction has to be there, it will always be there. Then
damp condition or undamped condition?
Damp conditions. All are damp conditions. Both are damp conditions. So as I was talking about TMT parameters, so you can see here, these are the parameters, tube mass damper parameters, that is zeta t, okay, zeta t and mu, that is the mass ratio. So if we look at the graph on the next picture, you can see a few cases has been studied. So first case could be, I have written in case 1, case 2, case 3, case 4, but first case might be for reducing the sinusoidal response of the main structure. Second could be for reducing the response of the main system due to base excitation.
Sir is working as Managing Director at Sami Infrastructure and Properties Private Limited. Sir is alumni of COEP Pune. Initially, he has also worked as a faculty member of COEP. Thereafter, he is inventor and patent holder of the Graviloft technology under IPR of Government of India. It is an innovative design technology construction which is related to the earthen work, that is retaining wall. Thereafter, he is awarded as Eminent Engineer Award on behalf of Maharashtra and Goa State, conferred by Indian Society of Technology, Education Technology, New Delhi. He is ex-chairman of Indian Geotechnical Society. Thereafter, he has received a grant of 40 million rupees for the research proposal at IIT Bombay. Currently, the grant is through MHRD. He has provided design building solution for 25 and 30 meter height of retaining wall. We will be listening it in this session. Thereafter, he has worked as design and consultant and design and building solution of Graviloft retaining wall at various corporates, MNCs and government organizations. At this age, he is currently a research scholar at IIT Bombay. So I request you all to have a round of applause to welcome him. One thing I shouldn't tell you.
First step. To explain the concept of Graviloft technology, the shear failure pattern that originates from the intersection of base concrete and retention surface is shown. Then, construction of wall is carried out in stages with a process of simultaneous backfilling. Once the construction of the wall reaches the designed height, an RCC raft is laid by casting of a raft on the already placed backfill. Now is the crux of this technology. The erection of this loft into the failure plane breaks the shear failure pattern, giving birth to a new shear failure plane, which originates from the intersection of the loft and the new retention surface. The balance construction of the wall and backfilling is then carried out. In multi-loft graviloft construction, for heights of more than 6 to 7 meter, multiple gravilofts can be provided accordingly. This merit gives the graviloft technology utility for much greater heights. Interestingly, as the height of retention increases, the percentage of saving due to adoption of graviloft walls increases. When there is no loft, the lateral earth pressure diagram is a single triangle, and base pressure distribution is triangular, giving more pressure intensity towards the toe. In graviloft technology for single loft, earth pressure is in the form of two reduced triangles, and the pressure is either uniform or trapezoidal, which exploits the full bearing capacity of the foundation and eliminates the possibility of tilting or uneven settlement. The backfill, which is responsible for generating lateral thrust in graviloft walls, is unstable soil mass above the shear failure planes.
So this is the basic, इसका जो डिजाइन का फिलोसॉफी ये है, और ये फिलोसॉफी आई जॉटेड दिस, मैंने ये डॉक्यूमेंट किया है 2004 साल में. आज मैं आपको जो वीडियो देख करके दिखाया ये 2000 साल में हमने बनाया हुआ आपको दिखा रहा हूं. एक टेक्नोलॉजी में प्रेजेंट करके दोस्तों आज करोड़ों के बिजनेस मिलते हैं, और मैं बता रहा हूं कि हर किसी का स्पेशलिटी होता है. मैं भी 20-23 साल से इसमें इतना मेहनत कर रहा हूं, दिन और रात सिर्फ इतना ही. आप बोलेंगे क्या करते हैं बिजनेस, तो मेरा ये बिजनेस है. इसमें आगे बिल्कुल वी हैव डेवलप द टेक्नोलॉजीज, हमने आगे भी कुछ काम किया, लेकिन मैं बता रहा हूं पहला टेक्नोलॉजी. और दोस्तों बताने मुझे बिल्कुल खुशी होगी कि जब हम एकेडमिशियंस बाहर जाते हैं, अभी सर चले गए अपने जो जुड़े थे डोबरे सर, तो जब हम एकेडमिक्स बाहर जाते हैं इंडस्ट्री में, तो इंडस्ट्री में लोग स्वीकार नहीं करते. इंडस्ट्री में लोग हमेशा अपने दे आर ऑलवेज सस्पिशियस कि आप क्या बताएंगे, आपको क्या मालूम है. बिकॉज हम कुछ बातें थ्योरी बात करते ज्यादा, हमारे तरफ से प्रैक्टिकल बात होती नहीं, क्योंकि ना कुछ बातें ऐसी है दोस्तों कि प्रैक्टिकल अंदाज अलग होता है. हम थ्योरी बहुत अच्छा तरह से जानते हैं इंजीनियरिंग का, लेकिन वही बात जब एग्जीक्यूशन में जाते हैं तो उसमें थोड़ा सा मॉडिफिकेशन होता है, थोड़ा सा अंडरस्टैंडिंग होता है. एग्जाम्पल के तौर पे बताया जाए तो मैं शुरू में डिजाइन करता था, तो मुझे ये जो स्टेजेस है ना कंस्ट्रक्शन के, ये मुझे पता नहीं था उस टाइम कि प्लाईवुड क्या साइज का मिलता है, प्लाईवुड इज यूज्ड फॉर द कंस्ट्रक्शन करने में, उसका मुझे कुछ पता नहीं था. मैं कुछ भी डायमेंशन लिखता था 0.677. अरे क्या 0.677, लोग पागल बनाते होते कि टीचर आप ठीक है, बहुत अच्छे प्रोफेसर, वो इंजीनियरिंग कॉलेज के है, ठीक है, उसके मत बोलो अभी क्योंकि बड़े कॉलेज का है. लेकिन उसके दिल में हमेशा रहता था सर कुछ प्रैक्टिकल बोलो ना आपके. तो दोस्तों ये लोगों ने मुझे बहुत सहा, बहुत मुझे एक्सेप्ट किया, लेकिन बाद में मैं सीखा, इन लोगों से सीखा, लेकिन मैं कभी शर्माया नहीं, अपनी गलती दुरुस्त किया. और आज मैं मार्केट में, आपको लगता होगा कि लेकिन मार्केट में आज है ना, हम ऐसे उंगली पे करोड़ों का ट्रांजैक्शन काउंट करते हैं और सब बातें ऐसा होता है, लेकिन ये सब मेरे फील्ड में सिर्फ ओनली इन माय एरिया, लेकिन ये सब बात आने में थोड़ा टाइम गया. लेकिन आज इंडस्ट्री में वी आर द स्ट्रॉन्गेस्ट प्लेयर. मैं बता रहा हूँ कि इंडस्ट्री में एग्जाम्पल के तौर पर बताए तो सर परसों दिवाली के वक्त I got a call from गडकरी साहब ऑफिस, they referred me the वर्क ऑफ से देहरादून, उसके आगे जो अपना 4 धाम रोड बना रहे हो, वना क्या नाम है बताता हूँ, तो वहां पे उनका दीवार गिर गया रोड के साइड का. वहां तो बहुत सारे दीवार का काम चल रहे, रोड बना रहे, तो इट्स ए वेरी स्टिफ हिल साइड. जो हमारे इधर हम देखते हैं हिली साइड और ये कुछ भी नहीं उसके सामने, लेकिन उसका एक अलग ही नजारा है. तो वहां पे वॉल गिर गया, तो 18 मीटर हाइट का वॉल आ रहा था. उनके पास छोटे सोल्यूशन है. सो 18 मीटर के लिए मुझे आई गॉट ए कॉल फ्रॉम गडकरी साहब ऑफिस, सर ऐसा है, आई रेफर योर नेम टू द कमांडर बॉर्डर रोड ऑर्गेनाइजेशन एंड ही विल कॉल यू. तो कमांडर साहब का फोन आया कि पाटिल सर ऐसा. तो शुरू में देखो सर, किसी को भी महाराष्ट्र के बाहर हम ज्यादा गए नहीं, जो भी गए 2-3 स्टेट में हम गए, कभी बाहर जाने की जरूरत पड़ी नहीं.
पुणे में इतना मेरे लिए बिजनेस पड़ा हुआ है, इससे में बाहर जाने के लिए एक वक्त आया नहीं। और मैंने सोचा खुद का कि लाइफ भी जीना है और सिर्फ पैसे कमाना नहीं, तो एक अलग सोच होती है किसी। लेकिन ये काम जब आया, when it was referred by गडकरी साहब ऑफिस, then I took it very seriously. Then I talked with that guy on phone. दिवाली के वक्त उनको बोला कि सब दिवाली के वक्त में छुट्टी है मेरे को, कभी भी बोलो मैं आ जाऊंगा। And same thing happened. He said that सर परसों आना है आपको। You tell me बुकिंग में कुछ तो होते 5,000 का टिकट 17-18,000 रुपए का वन साइड फ्लाइट, बोले सर आ जाओ। बिना सोचे, यानी आना जाने का मैं बुक कर दिया बिना सोचे। मुझे पता है 10,000 का टिकट मैं 35-40,000 में ले रहा हूँ, लेकिन ओके आई डिड इट। फ्रेंड्स, ये सब बातें मैं अपना जज्बा बताता कि आई अटेंडेड दैट ऑफिस, आई अटेंडेड साइट, ऐसी बात की वो तुरंत वही उसी जगह पर उन्होंने मेरा प्रोजेक्ट सैंक्शन कर दिया। लेकिन कंप्लायंस करने में जो होता है, डॉक्यूमेंटेशन करने में, उनकी तरफ से वर्कआउट आना चाहिए, मेरी तरफ से ड्राइंग सबमिट होना चाहिए, उसको 1 महीना गया। लेकिन विद इन 2-3 घंटे में सब प्रोजेक्ट क्रैक, अभी वो आप पे काम कर रहे हैं। तो मैं आपको बताने का ये कि सर इंडस्ट्री में इस तरह से पहचान होनी चाहिए कि लोगों का आपको बिजनेस बाय योर रिकग्निशन पीपल शुड कम टू यू। तो ये जो टेक्नोलॉजी का सर शुरुआत की थी, आप कुछ लोग समझोगे कि ये जो लेटरल प्रेशर जो है हमने इसको, ये जो लॉक दिया है, ये लॉक की वजह से हमने कट किया, ये जो लॉक दिया इसकी वजह से कट किया। ये जो he was there with me, he guided me that you undertake this work. I said that since मुझे कुछ उनका अंडर काम करना ही था, तो मुझे कंपल्सरी काम करना पड़ा। Then I did it. Then उसको मालूम था कि एक बार मेरे दिल में चला गया तो फिर मैं उसको मार्केट में ले जा सकता। दोस्तों, इनको मैंने पहले पुणे कॉर्पोरेशन में इंट्रोड्यूस किया। उधर उनका कुछ उस टाइम 2000 की बात है, 10 लाख का काम था, उसको उस टाइम 1.5-2 लाख उनके बचे, 2 लाख बचे। तो इतना सेविंग होने के बाद देखो हमारे लिए खुशी थी कि हमने कुछ तो सेविंग करके दिया। सेक्शन भी हमने भी थोड़ा सा ज्यादा दिल्ली यूज किए थे कि पहला काम में कुछ लफड़ा ना हो। तो बाद में हमने इसका वो स्टडी करने के बाद पता चला कि देयर इज ए 25 to 35% सेविंग, 35% तक सेविंग हो सकता है। और हमारे सब जो इंजीनियरिंग के काम होते हैं सब लाख और करोड़ में होते हैं। आज जस्ट इमेजिन करो, 1 करोड़ का काम है जो कन्वेंशन डिजाइन किया हुआ है, वो यदि अपनी टेक्नोलॉजी से काम किया तो उसका कॉस्ट आ रहा है 65 to 70 लाख ओनली। और मार्केट में जो कंसल्टेंट हमारे बैठे होते, हमारे लोग होते, कोई अलग नहीं होते, तो उनका फुल टाइम बिजनेस है वो बहुत शाने होते हैं। हम जितने बोलते हैं हम टीचर ज्यादा, उनसे अपने से ज्यादा होते हैं। उनको पता चलता है कि यह होने से क्या होने वाला है। When we enter in the market, एक बार काम हो गया ठीक है, लेकिन दूसरे टाइम जब हम प्रोजेक्ट में खड़े हुए तो ऐसा गहरा उन्होंने मेरे पे वार किया कि मैं समझ नहीं पाया। वो बोलते थे क्या बात करे पाटिल आप, या अभी ये बता रहे, वो बता रहे थे, अभी ये बता रहे। अभी उनका रिलेशन था, साहब लोगों के सामने जोर से चिल्ला पाए, बोले देखो साहब, मेरा जो टेक्नोलॉजी का कहना है इज वेरी फर्म, उसमें कुछ चेंज होने वाला नहीं। आप मेरे को बार बार घुमा के जो बता रहे हैं ये मत करो। फिर इसके लिए मैंने क्या किया कि मैं समझ गया उस टाइम मार्केट में लोग कैसे करते हैं, तो मैं बोला कि जो मुझे कहना है ना टेक्नोलॉजी के बारे में, तो उसको एक बार लिखो, जॉट डाउन द थिंग्स, और लिखने के बाद उसका प्रेजेंटेशन तैयार करो। ये ऐसा प्रेजेंटेशन तैयार किया उस टाइम, आप बिलीव नहीं करेंगे, मुझे जो कहना है ये कहना है। फिर बाद में कहने लगे सर हमको मालूम है, बड़े बड़े लोग हमें मालूम है कि आप कहते हैं कि अभी सूरज इधर से भी इधर से आता है सर ऐसा कुछ, लेकिन कुछ भी बताते थे, कुछ भी चीफ इंजीनियर लेवल के लोग, क्योंकि उनका सेटिंग, उनका हमेशा का बिजनेस बहुत तकलीफ हुआ क्रैक करने में बहुत तकलीफ हुआ। लेकिन मैं बताता आपको, जब हमारा अपॉइंटमेंट हुआ कॉर्पोरेशन के कंसल्टेंट के पैनल पे, वहां की भी एक दिक्कत मैं बताता हूं। दिक्कत क्या थी कि सर कोई भी प्रोजेक्ट यदि आप डिजाइन करके देंगे तो आपको रिम्यूनरेशन कितना मिलेगा, 1% ऑफ द एस्टिमेट। यदि कोई काम आया, उसका यदि मैंने डिजाइन बनाया तो मेरा एस्टिमेट सपोज 65 लाख का, तो उसका कन्वेंशन से आएगा 1 करोड़। जो आदमी ने 1 करोड़ का एस्टिमेट दिया उसको 1% मिलेगा, और मैंने 65 लाख का दिया तो मुझे वही काम का मुझे 65 तो 1% फी ओनली। सबको कायदा समान। ये नहीं समझते थे कि मैंने सेविंग करके दिया, ये अकाउंट करने को तैयारी नहीं। उल्टा उसका नेगेटिव साइड क्या होने लगा, डिपार्टमेंट के लोग अरे इतना कम कर दिया, अभी इसमें कुछ बचा ही नहीं। कॉन्ट्रैक्टर बोलता है क्या सर आपने कम एस्टिमेट दे दिया, कुछ तो प्ले रखो, साहब के लिए प्ले नहीं, कॉन्ट्रैक्टर के लिए प्ले नहीं। हम लोग तो उसमें फिर मैं बोला कि टेक्नोलॉजी सेविंग करके कुछ फायदा है क्या, नहीं। कुछ दिन चला सीओपी के नाम पे, चलो प्रोफेसर साहब का सुनो काम करो, लेकिन बाद में बोलते थे प्रोफेसर साहब ये आपका ठीक नहीं, कुछ तो गलत है। मैं बोला कि भाई गलत है, इसका मतलब कुछ तो ज्यादा उधर का पावर बढ़ गया है, मनी पावर। तो मैं बोला कि क्योंकि देखो आदमी, एक प्रैक्टिकल बातें होती है। एक आदमी जो 1 करोड़ का डिजाइन देके उसको 1 लाख मिलता है, वो बोलता है सारा ये काम मुझे नहीं मिला तो ये आदमी को दिया तो मुझे 1 रुपया नहीं मिलता, उससे बेटर है साहब 35,000 आप ले लो, 40,000 आप ले लो। ये प्रैक्टिकल बात है बॉस। उससे क्या होने लगा कि उधर का वजन बढ़ते गया, मैं आदमी मुझे बाहर फेंक दिया, और मुझे बाहर फेंका नहीं, लेकिन मुझे सब पता चला कि यार कुछ तो गलत हो गया, बिकॉज द रिस्पेक्ट व्हिच आई शुड गेट बिकॉज ऑफ सेविंग आई एम नॉट गेटिंग द रिस्पेक्ट, सो इट्स बेटर आई शुड नॉट स्टैंड हियर, कि मेरे लिए जगह नहीं है, तो मैंने खुद ने वो बिजनेस छोड़ा। लेकिन आप बताओ कि उस टाइम का जो सिचुएशन था कि 1 करोड़ का डिजाइन देने के बाद कन्वेंशनल आदमी उसको 1 लाख फी मिलता था, उसका उतना ही सोच था। ऑर्गेनाइजेशन उस टाइम की हालत ऐसी थी, सब गवर्नमेंट सेक्टर जो थे, जो कॉर्पोरेशन थे, एमआईडीसी थे, ये एमएसआरडीसी, ओनली दीज ऑर्गेनाइजेशंस यूज्ड टू कंस्ट्रक्ट दीज स्ट्रक्चर्स, वही लोग ये काम करते थे, कोई प्राइवेट प्लेयर करता नहीं था। इसलिए क्या हुआ था कि गवर्नमेंट ऑर्गेनाइजेशन में सब लोग जब चलता था तो अलग स्टाइल से चलता था, जिसमें हमारा जो सेविंग करके थे उसका कोई वैल्यूएशन था क्या? नहीं। लेकिन एक वक्त आता है दोस्तों, बिफोर आई स्विच टू द नेक्स्ट अलग स्टाइल, मैं बता था कि इस दौरान क्या हुआ कि हमें 65 लाख का एस्टिमेट देने के बावजूद, 35 लाख का सेविंग देने के बावजूद मुझे 65,000 जो फी आता था वो भी कर्टल करके करते मेरे हाथ में 20-25 हजार रुपए आता था। ये सिनेरियो हो गया। देन व्हाट हैपेंड, वी चेंज दिस टोटल पैटर्न। इंडस्ट्री में बड़े बड़े प्लेयर आ गए। द फर्स्ट बिगेस्ट प्लेयर आई मेट इज ए लोड़ा ग्रुप। जहां लोड़ा ग्रुप का 19 करोड़ का प्रोजेक्ट था, उसको मैंने सब ऐसा काम किया ऑनेस्टली, उसका कॉस्ट हुआ 14 करोड़। मुझे बताया कि सर प्रेजेंट करो, तो आप जैसे बैठे ना, तो ऐसा पूरा मॉब बैठता था जहां पे कंसर्न होते थे, सभी डिपार्टमेंट के कंसर्न होते थे। सो दे डेवलप दैट लोड़ा सिटी, जो आपको मालूम है पलाव सिटी। ये पलाव सिटी क्या छोटा नहीं है सर, शुरुआत थी 150 एकड़ का, अभी उनका कम से कम 1000 एकड़ का पलाव सिटी बन गया है। उसके बगल में अभी मैं फिलहाल 2000 एकड़ का उनका रियल एस्टेट लॉजिस्टिक पार्क, जो उनका इंडस्ट्रियल सेक्टर है, वो डेवलप कर रहा हूं। लेकिन मैं बताता कि उस टाइम जो हमारा शुरुआत हुई थी, उनका जो प्रोजेक्ट था कि प्रोजेक्ट में पूरा बाउंड्री को, एक प्लॉट ऐसा था उनका कि साल में 2 महीना वहां पे पानी रहता था, ऐसा प्लॉट उन्होंने खरीदा और उसको पूरा पेरीफेरी को 5-6 मीटर का वॉल बनाया और वो पूरा आइलैंड जैसा डेवलप किया, जिसको आज बोलते हैं पलाव सिटी ओरिजिनल जो है। तो वहां पे उनका जो रिक्वायरमेंट था वॉल का बड़ा था। मुझे जब कॉन्ट्रैक्ट मिला हो तो उस टाइम मैं सोचा कि ओके आई विल वर्क फॉर दैट। सो मैं उसका पूरा डिजाइन किया, एस्टिमेट किया, सब कुछ किया। उसके बाद मुझे ऐसा हुआ कि 19 करोड़ का प्रोजेक्ट इज कमिंग डाउन टू 14 करोड़। तो मुझे बहुत खुशी हुई, इतना बड़ा प्रोजेक्ट 1% फी मिला तो 14 लाख फी मिला, बहुत बड़ी बात थी सर। लेकिन मैं बताऊं कि कुछ तो अलग ही लिखा था। जब मैं प्रोजेक्ट का पूरा प्रेजेंटेशन दिया, ऑल कंसर्न्ड वेरी हैप्पी, और डिस्कशन ऐसा होता था गवर्नमेंट स्टाइल नहीं, तुम्हारा बंद लिफाफे में दे दो, ऐसा नाटक नहीं, सब प्रेजेंट करो। इफ ऑल से एग्री योर प्रोजेक्ट विल बी एक्सेप्टेड, इफ एक्सेप्टेड देन कमर्शियल स्टार्ट। कमर्शियल खुली चलती थी, तो एक्सेप्ट लोगों ने कर दिया। फिर मुझे खुशी हुई, चलो एक्सेप्ट हो गया। तो मुझे लगता कि कंसल्टेंट से ज्यादा अपना कुछ सोच भी नहीं था। तो मुझे बाजू में लेके गए, बोले कि नाउ लेट अस स्टार्ट विद द कमर्शियल्स। कमर्शियल्स का शुरुआत हुई कि बोला कि ओके यू आर गिविंग 5 करोड़ ऑफ सेविंग, लेकिन प्रोफेसर पाटिल यू हैव टू प्रूव करके दिखाओ कि आपको करके दिखाना है। बोले सर बिल्कुल आई एम रेडी फॉर दैट। ये ऐसे जिगर थी पहले से, सर मैं दिखाता, लेकिन मेरे पास पैसा नहीं। आज कोई मार्केट में जाएगा, कॉन्ट्रैक्ट ले, कोई ऐसा बोल सकता है कि मेरे पास पैसा नहीं, बोले चलो भागा देंगे। लेकिन सीधा देखो, जब दिल से खुली बात है ना, मैंने बोला साहब मेरे पास पैसा नहीं, देन व्हाट इज योर एस्टिमेट, हाउ मच फंड्स यू रिक्वायर। बोलते देखो साहब ये ऐसा खुली किताब है, जो 14 करोड़ का कॉन्ट्रैक्ट था उसमें 10 करोड़ का मटेरियल था, जो मटेरियल भी बहुत सिंपल था, कंक्रीट और स्टील। 2 आइटम का कॉस्ट आता था 10 करोड़, और 4 करोड़ में लेबर कंपोनेंट था, शटरिंग था, प्रॉफिट था, ये सब 4 करोड़ में था। आप बिलीव नहीं करेंगे, उन्होंने देखा, बोले देखो आपने कंक्रीट का जो रेट पकड़ा है और स्टील का जो रेट है, ये हमारा एस्टिमेट, हमारा जो प्रोक्योरमेंट है उसके हिसाब से आपका 10% ज्यादा है, तो उनका कॉस्ट आता 9 करोड़। आप बिलीव नहीं करेंगे सर, उन्होंने मुझे बोला कि देखो पाटिल आपको हम ये पूरा मटेरियल हमारे रेट से सप्लाई करते हैं, ये जो 1 करोड़ का दिख रहा है डिफरेंस, 1 करोड़ का आप तुम्हारे प्रॉफिट में ऐड कर दो, तुम्हारे दूसरे आइटम में ऐड कर दो, लेकिन हम आपको सप्लाई करेंगे, आप ना मत बोलो। सर ऐसा मेरा जिंदगी का शुरुआत हुई कि बोले तो पैसा तो नहीं था, लेकिन उन्होंने मुझे पूरा मटेरियल सप्लाई का उन्होंने एक्सेप्टेंस किया। देन आई स्टार्टेड विद बाकी का थोड़ा बहुत इन्वेस्ट किया मैंने, लेकिन 1 करोड़ का जो गेन था, जो 1 करोड़ का डिफरेंस था, उन्होंने मुझे प्रॉफिट में ऐड करके बोला एक बड़ा डील होता है और बड़ी सोच होती है। और प्रोजेक्ट 5 साल चला, उसके बाद 3-4 प्रोजेक्ट और किए मैंने। लेकिन मैं बताता कि ऐसा हो सकता है, पैसा नहीं, हम रुक नहीं सकते, हमारे पास जो दिमाग की बुद्धि है उसको लेके आगे चलो, उसमें से योग निकलेगा, कुछ तो होता है। तो दिस इज हाउ आई स्टार्टेड जर्नी। फिर वहां पे जो काम किया मैंने, उसके बाद एक पता चला क्या यदि हम यहाँ पे एग्जीक्यूशन कर सकते हैं तो इंडस्ट्री में बाहर एग्जीक्यूशन क्यों नहीं कर सकते। और यहाँ पे मेरा सबसे बड़ा ब्रेक पॉइंट हुआ। बात ऐसी हुई सर कि जो मैं बताता ना 25 to 35% से, तो बहुत सारे बाकी के प्लेयर भी मुझे मिले कि जिनके पास में जाके आई डिलीवर दिस प्रोडक्ट, लाइक से टाटा ग्रुप था, देन पेनिनसुला ग्रुप था, ऐसे बड़े बड़े लोग हैं, कुछ मल्टीनेशनल कंपनी, उनको मिला मैं। और वहां पे जाके आपका जो उनके पास जो डिजाइन कॉस्ट होता था, जो बाहर का कन्वेंशनल का था, उसका हमेशा वो लोग भी बढ़ा देते थे। 100 रुपए का कॉस्ट 100 रखते थे, 120 130 बना देते थे। मैं 100 रुपए के ऊपर मैंने क्या किया, मैं बोला सर आपको 80 रुपए देता हूं। But I said, instead of 100 rupees of your actual design cost, I said that I give in 80 rupees. तो मुझे 65 to 80 ये 15% का जो है वो मेरे को बेनिफिट उसमें हो गया। और जब मैं खुद एग्जीक्यूशन करने लगा, वहां पे मुझे सबसे बड़ा ब्रेक पॉइंट मिला, वो जो बोलते हैं मटेरियल का क्या इंपॉर्टेंस हो सकता है। दोस्तों मैं आपको रियलिस्टिक बताता, सिर्फ कुछ तो लेक्चर देने के लिए और थ्योरेटिकल बात नहीं होना चाहिए। Clean engineering material.
A very nice initiative by government of okay. So now see, this presentation is very much related to the clean materials, the engineering approach we require for the next generation. My dear friends, when we are talking about this particular topic, clean materials, among the clean materials there are number of category of material according to their availability, their classification, it is available in market. But how one civil engineer or one mechanical engineer can able to utilize that in our day-to-day routine construction practices, that is the matter of concern. So, in this particular presentation, I am covering the brief introduction of the clean material. Secondly, the permeable pavement. This is the actual topic of today's discussion, how we can construct the permeable pavement. Because lot of research has been carried out till date, but unfortunately, there is no typical standard design method with which we can go ahead. And so this is the gray area where we can earn a lot. As per the earlier session speaker just ignited our minds in terms of the encashment of an opportunity. This is an opportunity to think twice towards this particular clean material as a paving material, because there is no standardization. If we could manage to give some typical design in this particular area, then that will be very much beneficial for each and everyone, for the budding engineers, those who are struggling to establish themselves in the market. Second one, we will discuss some case studies, conclusions and references. This is always the part and parcel of any presentation. Next please. Next. Keep reading for me. Why will you take it?
Okay. Is it good?
Yeah, this will be better. Thank you so much. Okay, so first of all, clean materials. We all are aware that whenever we are talking about some technical part, we all are very much concerned about the definition of that particular terminology. What is clean material? I hope everyone is familiar with Marathi, Hindi, English, everything. आपल्याला बऱ्याच संतांनी सांगून गेलेलं आहे की निर्मळ मन असायला हवं. व्हॉट डज इट मीन निर्मळ मन? म्हणजे आपण असा एखादा आपला शरीराचा ऑर्गन बाहेर काढून धुवून परत आत टाकतो का? We are not doing like that. We are always focusing on the thought process, the way with which we can handle that particular beautiful concept. And so the clean material is what? We are not thinking that that material is supposed to be washed. Yes, in civil engineering there is a requirement to wash the sand before utilization in construction activities. But there are so many other members or there are so many other what we can say the component ingredients are there that doesn't require any sort of cleaning. So what does it actually mean by the clean material? Clean material means what? आपण कधीतरी असं फिरायला छानपैकी गेलो, जे आपण आपल्या सभोवताली बघत असतो त्याच्याबद्दल आपल्याला जास्त प्रेम वाटत नाही, पण आपण हेच जर आपला एरिया आउट ऑफ द कार्बन what we can say the footprints available, China, USA, they are developed countries, they are having huge industrial what we can say the setups, and because of that they are utilizing, they are just purchasing the carbon or that particular carbon footprint remaining balance available with the nation, developing nation like India, and they are developing their countries. But this is not at all sustainable solution, and so we are thinking about the environmental impact. Second one, promote energy efficient. Energy efficient means what? Earlier we used to live in the homes where the flooring was covered with the cow dung. आधीच्या काळामध्ये शेणानं सारवलेल्या मातीमध्ये आपण म्हणजे जमिनीवर राहायचो, गोधडी घ्यायचो आजीनं शिवलेली आणि या सगळ्यामध्ये एन्जॉय करायचो. त्याचं कारण असं होतं की पांढऱ्या मातीच्या भिंती ज्या असायच्या त्या हिवाळ्यामध्ये आत ऊब द्यायच्या आणि उन्हाळ्यामध्ये थंड वातावरण ठेवायचे. हे सगळं आपण विसरत चाललो आणि आपण काय केलं, फक्त आणि फक्त कॉन्क्रीट, क्रश आणि अशा पद्धतीचं मटेरियल सिव्हिल इंजिनिअरिंग मध्ये वापरत गेलो. सो हिअर वी आर सपोज टू फोकस ऑन दिस पर्टिक्युलर एनर्जी इफिशियन्सी. What is the actual meaning that we will discuss in today's session. Next one, how we can able to contribute to a healthier built environment. Do remember and believe me, in 2050 there will be a concern related to the mental health, not related to the physical health. Because of the advancement in the medical sector, we can able to cure everything. Only we are unable to cure, that is nothing but our mind and soul. And this will happen only because of the surrounding. मी जिथं आहे, मी ज्या लोकांच्यात राहतो, मी जशा वातावरणात राहतो, that will affect. There is one slide. This will lead you to think twice whether to choose Pune, Mumbai or Metro City for your bread and butter. We will go through that particular slide. In 2050, 99% people would like to live, stay at their native, at rural area only, because that is nothing but the actual ways from where this growth has happened. Everyone would like to return back to their home, and this is the need of the era where we have to think twice. So this is nothing but the overall, we can say, the outline of today's session. We will move further. बोर व्हायला लागलं की सांगा, मी एखादी गोष्ट सांगतो. Okay, so recycle and recyclable materials. The very first is recycled concrete. Nowadays, this is the concern we have to look after while going for the BE project, PG projects, PhD projects. This is the very great initiative we can say in terms of the clean material where we can focus. So clean material is what? We are supposed to use the concrete. Nowadays, whenever we are going for the national highway and its upgradation to the expressway, or state highway and its upgradation to the national highway, or anything else, that means categorization or classification wise, if we are supposed to promote that particular road, generally what we are doing, we are not supposed to disturb the subgrade. We are only interested to replace the very upper layer of that particular construction of the road, that is nothing but the bearing course. We are having the two types of bearing course. The very first is nothing but the flexible pavement, second one is the rigid pavement, and among that, in rigid pavement, we are having the concrete, we are having the steel, and that particular concrete material, if you could able to use, just like this आपण दही लावायला, सगळ्या बऱ्याच जणांना माहित असेल, आपण काय करतो, आधीच्या ह्यातलं मुरवण घेतो आणि दुसऱ्या दिवशी दुधामध्ये टाकून त्याचं दही करतो. Similarly, if you could able to convert the material which is already utilized in the road surface as a bearing course, then what will happen? There will be a reduction in the requirement of the fine aggregate or the coarse aggregate. Already it is having the some what we can say the essence of the binder called as cement. and that will definitely. So during that particular process, we are always thinking that what might be the configuration of the steel design, how much percentage of the steel will be reutilized. So that particular aspect is much important in the clean material. Next one is the recycled glass. We all are working on the BE project, PG project, PhD project. We are utilizing some tertiary element into the mix, and so glass is one of the very best option we can say that could be just give additional value to the mix. Next one is the recycled plastic. We all are facing a great concern related to this particular parameter. So recycled plastic means what? When we are talking about the pavements, generally we can able to replace the fine grained aggregate by the plastic. So likewise we have to think during our day-to-day routine life. Next one, renewable and sustainable resources. Now after recycle and reusable material, this is another category where we have to focus. Why I am sharing this with you? Because how this particular topic is supposed to be lead toward the permeable pavement, that we have to figure out first. There is one typical correlation and that we need to find out. The bamboo, as I already told you, the carbon emission of similar, or we can say the one, if we are producing the 1 kg of the steel, it is emitting 1.75 ton of the carbon. In same line, if we are just burning the 1 kg of the bamboo, which is grown at fullness after 3 years of its cultivation, then it is totally matured bamboo. If we are just burning that particular bamboo of 1 kg, then it will emit only 0.25 kg of the carbon, and that is the big difference, because of which we supposed to lead toward this particular concern. Now see, the bamboo plantation is very much easy. Once you are planted, it is, you need to stop that particular, what we can say, the spread along and across the field. तुम्हाला स्वतःला त्याला कुंपण घालून द्यावं लागतं. अदरवाइज ते बांबूचं बेट इतकं वाढतं की मग ते आवरणं शक्य होत नाही. So there is a requirement of diaphragm walls rather while cultivating the bamboo species. So it is giving you the much, what we can say, the outcome, agricultural outcome. And whenever we are thinking about this particular plantation, at the same time you are emitting oxygen. Okay, only during the night time it will emit the CO2. Otherwise, for complete day, it is supposed to add some additional essays to the environment. So this is one of the renewable source. Next one, cork. We all are aware in highway transportation engineering, we are utilizing this particular material. Then wood from the certified sources. These are another concerns. Okay, I am not going detail into this. Now, next point, the low impact building materials. So natural stone we are generally utilizing. Then low VOC, volatile organic compound paints and finishes. Nowadays there is a advertisement, very beautiful advertisement by Ranbir Kapoor. Okay, related to the paints. Because after painting any premises, we generally keep that particular premises open for minimum 48 to 72 hours. So that particular environment will supposed to absorb all the, what we can say, the emissions, coal gases, and then thereafter we are supposed to enjoy the normal oxygen. And that is the concern. That's why this is another alternative in terms of the low impact building material. And the earthen material, we all are aware that nowadays the trend again came into picture. जशी फॅशनच्या बाबतीत आपण म्हणतो ऑब्झोलिजन्स, बऱ्याच वेळा ट्रेंड फॅशन चेंज मुळे बऱ्याच वेळा असं होतं की ज्यावेळी अमिताभ बच्चन एखाद्या पद्धतीचा म्हणजे अटायर मध्ये असायचा शर्ट पॅन्टचा, तो आता पुन्हा परत 2-3 डेकेड नंतर पुन्हा येतो. Similarly, now everyone would like to have the specific food in the earthenware. Why? Because it is adding some essence, and earthenware not emitting anything. Okay, and it is very easy to degrade. So similarly, when we are talking about the earthen material, here we have to think twice and we have to give the promotion to the earthen constructions. Okay, so these are some parameters we have to think. Next, when we are talking about the energy efficient material, the very first is insulation material. Whenever we are constructing auditorium, whenever we are thinking for the any public addressing halls, at that time we are thinking twice for the ventilation. Okay, suppose this particular hall requires 10 ton of the AC requirement. Despite that, whether we can able to provide the proper ventilation system, this is another concern. So the insulation materials are available. High performance windows, they are also available, and we have to think whenever we are just selecting the clean materials. Next one, the innovative eco-friendly materials. So these are some eco-friendly materials. The very first is solar tiles. You all are aware that one typical canal system is totally covered with the rooftop as a solar panels. May I know the name of that canal system? एक छान पूर्ण म्हणजे ओरिजिन पासून शेवटच्या हेक्टर पर्यंत पाणी पुरवणारा एक कॅनल आहे की ज्याच्या टॉप वर पूर्णपणे सोलर पॅनल बसवलेले आहे. डू यू नो द सोलर बेस्ड एअरपोर्ट इन इंडिया? केबीसी बघितलं पाहिजे सगळे. कोची. Okay, so when you visit that particular place, you came to know that how much energy is available and why we are purchasing the paid resources against that. So likewise we have to start thinking in that particular direction. So solar tiles is one of the options. Nowadays see, when we are supposed to have the solar tiles, then what will happen? There are maximum area, open area available in the buildings, commercial and public buildings or private buildings also, and we can able to utilize that area with the solar tiles. Next one is the geopolymer concrete. In earlier session also, sir told about this particular geopolymer. We all are known the xanthan gum, cellulose and n number of geopolymer things available in market, how we can able to use. And why? Because there is a very important parameter called as low carbon emission, and that's why we are focusing on the same. Now what are the benefits of clean material that we will see, and then we will move towards the topic. The very first is environmental impact. That is the very first point we have discussed in the very first slide. Second, healthier space, then sustainability and energy efficiency. So these are the 4 points for which we are thinking to go for the clean materials. Now what are the research projects we can handle under this particular tagline of the clean materials? My dear friends, always try to think that whenever there is a problem, there is a solution. But if you are able to just give the solution at very, what we can say, at very correct time, at appropriate time, then you can able to encash the same. असं म्हणतात की जगामध्ये एक स्वप्न 7 जणांना पडतं सारखं. मग 7 जणांना ज्यावेळी स्वप्न पडतं त्यावेळी 7 जणांमधले जवळपास सगळे झोपलेले असतात. स्वप्न पडतं म्हणजे जागे पण इतर पडणार नाही. झोपलेले असतात. मिडनाईटला एकदम म्हणजे काय म्हणू आपण छान मस्त झोपेत असताना स्वप्न पडतं. त्यातल्या 3 जणांना जागच येत नाही बिकॉज ऑफ देअर फेट. त्यांचं दुर्दैव असतं आणि ते जागेच होत नाही. ते एन्जॉय करत असतात स्वप्न, पण ते त्याच्यावर ऍक्शन घेत नाही. 4 जण स्वप्नामध्ये जागे होतात, थोडे बहुत जागे होतात. त्या 4 मधला 1 जण असतो, तो म्हणतो यस चांगली आयडिया, आपण याच्यावर जरा ऍक्ट करू, उद्या करू. त्याचा उद्या कधी येतच नाही, तो झोपून जातो. उरतात 3. त्या 3 मधला 1 म्हणतो यस ह्याला पुढे कसं एक्सटेंड करता येईल. परत म्हणतो चाललंय ते बरं आहे, कुठे ह्याच्यात डोकं घाला, तो पण सोडून देतो. राहिले 2. त्यातला 1 जण जो असतो पूर्ण प्रोसेस फॉलो करतो. काय केल्यावर काय होईल, ही खूप चांगली संकल्पना आहे, असं आहे तसं आहे, सगळं विचार करतो. बट ही नॉट एबल टू मेन्शन इट और बुक इट ऑन द पीस ऑफ पेपर. And the only one person who is able to awake from that particular sleep, who is able to write down each and everything on a piece of paper, could make it possible in terms of the encashment. जे विकास पाटील सरांनी जे सांगितलं ते आपल्या सगळ्यांना, बऱ्याच जणांना, आता ते मगाशी जी टेक्नॉलॉजी सांगितली ती बऱ्याच जणांना असं वाटतं अरे हे मला पण सुचलं होतं. बऱ्याचदा असं होतं एखादं पेटंट येतं. एखाद्या रेल्वेच्या प्रवासामध्ये भारतामध्ये सगळ्यात वाईट गोष्ट काय असेल तर रेल्वे प्रवास. तो ह्याच्यासाठी म्हणतो की बरेचसेच पेटंट रेल्वेमध्ये 20 रुपये 50 रुपयाला एक च्या नावाने विकले जातात. देर आर सो मेनी गुड वाईज आयडियाज अवेलेबल इन मार्केट. बट व्हॉट हॅपन, आपण आपल्या चांगल्या जवळच्या मित्राला आयडिया सांगायला जातो. त्याला पहिली गोष्ट म्हणजे चांगला मित्र कोण, तर तो तुम्हाला टीच करून चांगल्या गोष्टी शिकवेल. तो आपले मित्र इतके चांगले असतात की आपण त्याला आयडिया सांगितली की आपल्याला तो वेड्यात काढतो. ही नेव्हर एव्हर सपोर्ट यू. आणि म्हणून असे चांगले आयडियाज असलेल्या गोष्टी रेल्वेमध्ये आपल्याला 20 रुपये 50 रुपयाला मिळतात. Science is science is having the very tremendous power. If we could look towards it in positive way, it will just give you the great returns. आणि म्हणून सकाळी विकास पाटील सर जे सांगत होते ग्रॅव्हिलॉक सिस्टीमच्या बाबतीत, तर जिओटेक्निकल इंजिनिअरिंग शिकलेल्या सगळ्यांना तो कन्सेप्ट पटला असेल. सगळ्यांना वाटलं असेल नवं काय. नवं हेच होतं की ते स्वप्नातनं जागे झाले, पीस ऑफ पेपरवर लिहिलं, ऍग्रीमेंट केलं शासनाबरोबर आणि सिस्टीम त्यांच्या नावावर झाली. So this is the way with which we have to look towards this research topic. Now what we will do, we will go through the number of research topics available in line with the clean material, where till date very few patents have been filed. सो आजच्या सेशन मध्ये तुमच्यातल्या एखाद्याचं एक जरी पेटंट झालं, दॅट माइट बी द आउटकम ऑफ द सेशन. कारण हे ट्रेडिशनल मी वेगळं काय मी स्वतः लिहिलेलं काही सांगत नाही. इट इज ऑलरेडी अवेलेबल इन मार्केट. बट व्हॉट आय एम थिंकिंग, how we can able to look towards that topic so that one can able to get richer and richer out of that particular project. That is what the actual outcome of this particular project. Now see, the very first research concept is recycled material. We all are aware that there are number of material available which is already implemented, executed through construction. How we can able to reutilize, that is the very first concept. Next one, natural materials like bamboo, timber or anything else. How we can able to add essence to the structure, that is another concept. Low carbon cement. Okay, but I always prefer to go without cement. Okay, why? Because when we are thinking about the cementitious material is what, there is an environmental impact. So this is also one of the concern. Next one, green insulation. We all are aware about the global warming. What will happen? What is happening to the our annual precipitation overall the India? That is another concern we need to discuss with. So this is one of the good research topic. And the next one is nothing but the permeable pavement, solar material, composite material, bio-based material. So among these, the number 5 permeable pavement, which is having the very less importance in our India. Why? Because luckily the western Ghat of the Maharashtra is receiving the good precipitation annually. Secondly, with the good deeds of our, what we can say, the elderly generations, we are receiving the good precipitation because they have planted too many species. But now we are towards the deforestation. We are not looking towards the LULC, land use and land covers. We are not at all worried about the topography of the area. We are only believing in the competition and the comparison, and so we started building the concrete structures. प्रत्येकाला नोकरी लागल्यावर पहिलं स्वप्न असतं माझं स्वतःचं घर व्हावं. ते आई वडिलांच्या सोबत व्हावं की नाही हा परतचा प्रश्न आहे. पण माझं स्वतःचं घर असावं आणि ते पण फ्लॅट सिस्टीम मध्ये असावं, कारण बंगला परवडण्या एवढे आपण श्रीमंत झालेलो नसतो मनानं आणि आर्थिकदृष्ट्या पण. आणि मग अशा वेळी काय होतं, मेट्रो सिटीमध्ये मोठ्या मोठ्या बिल्डिंग कव्हर केल्या जातात आणि ह्या कॉन्क्रीटच्या जंगलामध्ये लँड यूज पूर्णपणे डिप्लीट केलं जातं. अँड दॅट इज द रिझन आय हॅव चूजन दिस पर्टिक्युलर टॉपिक, द परमेबल पेमेंट, बिकॉज what will happen to the bore wells or the open wells after 3 decades? This is the concern of today. Okay, there will be a scarcity of water. There is a typical, what we can say, the water supply mafia, those who are running their businesses in the metro cities. Pune, Bangalore, तुम्ही कुठेही जा, तिथं टिपिकल एरिया असतो की जिथं तुम्ही पाईपलाईन करून म्हणजे कॉर्पोरेशनचं पाणी पोहोचू शकता. But they are having the great opposed to that particular system. The only reason is that they like to earn money out of the supply of the water through their tanker systems, and that is the reason how we can deal with such a sort of mafia. If our borewells are producing the good, what we can say, the discharge, then why we are depending on others? And this is the reason I have chosen this particular topic. Now see the next point. When we are talking about the figure and facts, there are some typical Now see, first of all we will look toward these particular figures. Okay, now see, this is nothing but the figure and facts where we can believe. Being a technical person, no one can believe directly on the general statements or the vague statement of the theoretical part. So here is the IMD latest database available. If it's shared with the share होत नाही.
लिंक ओपन करायची का?
हा लिंक डायरेक्ट ओपन व्हायला पाहिजे. तिथं नाही का? In the carbon, and that is against our GDP, it is very less in comparison. If you are talking about the USA, its GDP and its carbon emission, they have to purchase the carbon or that particular carbon footprints, or we can say the carbon emission related the permission from the developing country like India. So though this is the very good sign for us, but at the same time we have to think that how we can again supposed to reduce this particular contribution from 7 to 0. Okay, आताच्या काळात काय झालंय की मोठे उद्योग सुरू करायचे असले तर काय करतात लोक, एन्व्हायरमेंटल क्लिअरन्सची जी फाईल असते त्या एन्व्हायरमेंटल क्लिअरन्स मध्ये तुम्ही CO2 किती इमिट करणार आहे ते बघतात. तुमचं रेंज असते समजा सो अँड सो टन पर इयर, त्याच्या अगेन्स्ट तुम्ही किती करता एक्स्ट्रा तर तुम्हाला चार्ज बसतो. मग तो तुम्हाला दुसऱ्याकडनं विकत घ्यावा लागतो की ज्याच्या इंडस्ट्रीला त्यानं वापरलाच नाही ते इमिशनचं नाव. ओके, सो दिस इज लाईक द ऍडजस्टमेंट ओव्हरऑल द ग्लोब. आणि म्हणून ह्याच्या रिलेटेड समिट होतात आणि तिथं मग हे भांडण जे आहे ते अशा पद्धतीने डेव्हलपिंग कंट्रीला थोडंफार.
Engineering and design. He is chairman of various subjects at the University of North Mara University. He has worked as and currently also working as NAC and MBA coordinator of the institution. So it is our privilege to have you sir in our institution. I request our principal sir to felicitate Solanki sir.
You see, slums were not existing 100 years ago. 100 years ago, there was nothing like a slum area. Today, you enter into any city, the city is encircled by a slum area. A locality where the poor people reside, a locality where the incineration prevails, where the pollution prevails, where the unhygienic conditions prevail, where the poverty prevails. You see, a particular time the rains come, heavy rains come, a particular time when the mild showers come, a particular time the sky becomes clear, then there is a good crop. If this pattern is disturbed, throughout the year you will have same quantity of outfall, same quantity of water is falling from the sky. But if this pattern is disturbed, the crop will be failed. There was a senior scientist from Food and Agricultural Organization. He visited our college and he said one thing. By the year 2025, and world 75% remaining population consume only 25% of energy. So our contribution to the pollution is very less. The contribution to the pollution for these rich countries is very high. So that uneven distribution is also there, and that must be recognized. Energy use pattern is not same throughout the world. Even in our country, if you see the people living in the villages, again, one of the 5 basic elements of the nature, water is one, and this is the water crisis we are facing. In fact, because of development of science and technology, our living standard has improved, but the life quality has degraded. Abdul Kalam has once said that in the next 20 or 30 years, we will have colonies on the Mars, on the moon, in the space we will have hotels, we will have picnic resorts. That will be the living standard in the coming time, next 20 or 30 years this. But what is the life quality? Even for the water we have to fight. Even for the food people have to fight. Even for the life protection, you will have to fight. So life quality is basically degrading, and that should not happen. So in my today's lecture, I am going to discuss about why we are concerned about environment. What are the consequences we are going to face in the coming time, and what we can do, that is most important thing, what we can do to prevent these basic consequences, what should be our role. So let me start with a very basic question, that what is environment? Environment, everybody knows, if you refer to the dictionary meaning, it is our surrounding, whatever you see all around. But for sitting in this room, what do we see all around? We see these things. We see the land, the water, the sky, the plants, the human beings, animals, property, air, microorganisms, and the list can be very long. All these things we see all around. So in one word I can say these things are, they are the different forms of creation, different forms of energy according to the basic, because energy and mass are convertible, so we can say these are the different forms of energy. You see, our entire knowledge of science, our entire knowledge of spirituality is based upon one and one concept, that energy cannot be created, it cannot be destroyed. If you violate this law, the science will be, the basic principle of the science will be violated. The science will become baseless. Spirituality also depends upon one very basic concept, that the soul is immortal. Nenam chandati shrani, nenam dati pavaka, nachenam gledante pinenam shoshiti maruta. I do not connect it with any religion. I connect it with the spirituality. I connect it with the basic philosophy, basic Indian philosophy. But you see, what I see all around is not only the energy in time and space. Of course, there is energy in time and space, but the picture is incomplete. There is one more thing which is going on, that different forms of energy are interchangeable. Different forms of energy are interchangeable into one another. See, they describe the complete picture. Again, one shloka I have referred to, that Vasanti Jinnani Yatha Vihai Anyani Granati Aropani Tatha Shadnani Vihai Jinnani Anyani Sanyati Navani Vedi. The way we change our clothes, the soul changes the body. So energy can be converted from one form to another form, but it cannot be destroyed. These are the two basic principles which we follow in spirituality, we follow in science also. So we can define environment as energy in time and space which can change the form. E is equal to m into c square. But again, this is not a complete picture. In nature, we see that different type of cycles are going on. Of course, E is equal to m into c square is the cycles going on, but these cycles are maintaining a sort of equilibrium with each other. Equilibrium is maintained, relative equilibrium is maintained by different cycles. I explained with a simple example which everybody knows as a student of science, that air contains 21% oxygen. That figure is always constant, but this figure is not static, that figure is dynamic. Continuously we are inhaling the oxygen, continuously we are adding the oxygen. So a cycle is going on. So every figure in the nature is a dynamic figure. Every figure in the nature is a dynamic figure. And this dynamism is leading to a sort of equilibrium. This is a picture of Professor Fritjof Capra. He is a well-known physicist. Once upon a time he visited India. He just visited Bombay also. So he was just lying on a beach and he had a realization. He thought that the cosmic rays are coming from the sky, from the space, and continuously the formation of the creation and destruction cycle is continuously going on. So this formation and creation resembles the dance of Lord Shiva. So he wrote a paper on that, and that paper was based on that paper. This idol was Lord Shiva. He established in the Particle Research Laboratory of Geneva, in front of Particle Research Laboratory of Geneva. So that shows that the universe, in the functioning of universe, nothing as such is important, because nothing can be destroyed or created. But it is a pattern which is important. In environment, it is the pattern which is important. They see dance is a process. It's not a physical entity. In the same way, environment is also a pattern. It is not a physical entity. If you describe environment as a something materialistic, some component, it will be an incomplete picture. In the complete sense, environment is a process. So this process has been described here in the form of Lord Shiva's dance. And this idol has been established in front of the Particle Research Laboratory of Geneva, where they are searching for the God particle. So in the definition of environment, the word equilibrium is very, very important. When equilibrium is disturbed, then the pollution is created. Now we come to the technical definition of the word environment. Till now I have discussed the conceptual definition of the word environment. Technically speaking, environment is land, water and air and the interrelationship which exists amongst and between land, water and air, human beings, animals and property. Now here the interrelationship is very important and that refers to cycles. That refers to the cycles. And the definition of pollution I explained with the help of an example. Our air contains 78% nitrogen, 21% oxygen and 0.03% carbon dioxide. Now everybody knows that carbon dioxide is a pollution. Can I make carbon dioxide as 0%? The life will come to an end if I make carbon dioxide as 0% because it is essential for the survival of plants. And when plants survive, then only we will get oxygen. So can I make oxygen as 100%? If I make oxygen as 100%, everything will start burning. So neither I can make oxygen as 100% or I can make carbon dioxide as 0%. It gives me a very important concept that nothing as such is a pollution. We talk about pollution, but nothing as such is a pollution because everything is a creation of God and God cannot create wrong things. Everything is the creation of God, but it is a concentration of anything. It is a concentration of anything which becomes a pollution. It is the excess of something, it is the less of something which becomes a pollution. So this is what is the technically accepted definition of the word pollution. It is the concentration of anything which is or maybe uses to human beings, animals, plants or properties. That is called as pollution. So we have seen the two important definitions, conceptual definition of environment and the definition of pollution. Now we come to the fact that how this environment is being affected by our engineering, science and technology. Now let us see the engineering. We are all engineering students, engineering teachers. You see, engineering, the word has come from engine. Wait for a minute. The word engineering has come from the word engine. Engine is a machine which is used for dynamism and production. Machine which is used for dynamism and production. For example, your vehicle if you take, you use vehicle because you want more speed of transportation. A calculator or computer you use because
Such as the energy crisis, here is one of the main challenge in front of the world. Then populations and pollutions, here is one of the challenge. Here is the one more point, is the tremendous energy wasted in the form of heat. Then constant uninterruptible power requirement, efficiency decreasing in the electronic systems, and last one is the energy challenges are the modern trends. These are the various challenges in front of the world. Then the question arises, how to overcome these problems? What is the solutions for these problems? Then in that case, just
Okay, Rakesh.
See that? Here is the what is the solution? Then here I am giving the one point is the thermoelectric generator module is one of the alternative source of energy. Then let us see how these thermoelectric generator known as the green energy. Then before starting the basic concept of the thermoelectric generators, then what are the applications of the thermoelectric generators, I want to focus on some of the energy statistics, in which the picture shows the waste heat to electricity, in which if you see the number of the primary energy sources such as thermal power plant, nuclear power plant, automobile sectors, factory, then waste incinerators, these are the primary energy sources. And in through these primary energy sources, if you see the statistics of the energy, in which only the 34% of energy is used by these primary energy sources. Then remaining energy, it is in the form of energy losses, or you can say that the waste heat. Then most of the researchers think about the waste heat or the energy losses. If this waste heat or energy losses reutilize or recycle as an input to the thermoelectric device or thermoelectric modules, then you can generate the electricity. Here is the basic concept of the thermoelectric device. Here in this picture, it is clearly shown that the waste heat or energy losses, it is used as the input to the thermoelectric modules, and the thermoelectric modules convert the electrical energy, and again that electrical energy it is reutilized, or you can say that it is a retrieval of the energy. Then again one question is arise, why we need the thermoelectric generators? Here is the two pictures or two examples, in which first example related to the power station. In the power station, 2/3 parts of the energy it is lost, or you can say that the lost energy waste heat. Then in the second example, heat energy produced by the burning of fuel. That heat energy is used as a input to the turbine. Due to the heat energy, the turbine gets rotate and it converts into the mechanical energy, and mechanical energy is used to rotate the generator and it produces the electricity. Here these are the two examples of the conventional power generations. Then due to some of the limitations, we are think about the alternative source of the energy. And again, the answer for these two conventional resources, it is nothing but the thermoelectric generator. Then the basic concept of the thermoelectric generator, it is nothing but the thermoelectric effect. Then what is the thermoelectric effect? Thermoelectric effect, it is nothing but the direct conversion of a temperature difference or the temperature gradient into the electric voltage, and vice versa also. And it is possible only through the thermocouples. Then two devices which is based work on this thermoelectric effect. One device means it is the thermoelectric device creates a voltage when there is a temperature difference or the temperature gradient. And conversely, when the voltage is applied to the thermoelectric device, then it creates the temperature gradient effect on each side. Means after applying the voltage, then it creates the one hot side and second is the cold side. These are the two devices which works on the thermoelectric effect. Then how it is possible? How it is the effect is occurs, means how the voltage is generated through the temperature gradient, or how the two surface shows the hot surface and cold surface due to after applying the currents. It is only possible due to the atomic or you can say that the charge carriers. Due to the charge carriers, it is possible to create the thermoelectric effect. Then this thermoelectric effect, it is categorized into the three parts. First one is the Seebeck effect, then Pelter effect, and Thomson effect. These are the three different effects on which the thermoelectric device work. Let us see one by one in a brief. First one is the thermoelectric power generation. This thermoelectric power generation, it is invented by the scientist Seebeck in 1822, and this effect is known as the Seebeck effect. Then what is the diagram indicates? In this diagram, you see the two types of the semiconductor is there. One is the N type of semiconductor and second is the P type of semiconductors. Both the semiconductors which are metallically connected to each other, and when these are the metallically connected to each other, at that time it creates the thermocouple. And when the voltage is applied to the circuit, then due to the movement of the electrons, means electrons moves from the P type to the N types. In that case, there is a charge carrier is there, and due to this charge carriers, the thermoelectric device or thermoelectric modules, it creates the voltage, and it is possible only because of the temperature difference. If you see the pictures, in the picture, above sides it is the heat side, or you can say that the hot side, and bottom side is the cold side. And due to this hot temperature and cold temperature, there is a temperature gradient is there, and due to which it creates the voltage. Here is the such a type of effect, it is known as the Seebeck effect. The next one is the thermoelectric cooler. Previous one is the thermoelectric generator. Here is the thermoelectric cooler. This thermoelectric cooler, it is work on the opposite to the thermoelectric generators. Means here, this thermoelectric cooler, it is developed by the Jean Peltier in 1834, and it is based on the Pelter effect. And here, in this diagram, same here it is also the P type and N type of semiconductors, both are metallically connected to each other. But here, in these circuits, you have to apply the current. You have to apply the current into the circuits, and due to this current flows through the P type and N type of semiconductors, and here is it creates the hot effect and cold effect on each side of the thermocouple. In the previous one, there is a generation of voltage due to the hot side and cold side temperature. But here, in the Pelter effect, you can apply the current to the circuit, and it gives the two effect. One side is hot and other side is cold due to the atomic charge carriers. Then, and here, the electrons move from the N type to P type of material absorbing thermal energy from the cold junctions. And for the hot sides, the electrons dump their extra energy at the hot junctions as they flow from N type to the P types. Due to which these movements, it creates the hot effect and cold effect on each sides of the thermocouple. The third type of effect, it is the Thomson effect. Here, in 1851, the Thomson suggested that when the current flows through the unequally heated conductors, then heat is evolved or absorbed by the conductor. And such types of effect is known as the Thomson effect. Here, two pictures. The first one, in the first picture, consider the copper, it works as a conductor, and one side of the copper, here is the heat source is applied to the one end, and other end is free. Then, as per the Thomson concept, the current flows from the high temperature to low temperature. Then, due to this temperature difference and flow direction of the currents, the conductors evolve the energy to the atmosphere. And such a type of effect, it is named as the positive Thomson effect. And in the second picture, here is the example of the iron. And same concept, here is the one end is heated and other end is free. And due to the current flows from high temperature to low temperature. In that case, the energy is absorbed by the conductor. And then Thomson suggested that it's a negative Thomson effect. These are the three types of the effect which is based on the thermoelectric concept. Then here is the main topic is the thermoelectric module. The figure shows or picture indicates the structure of the thermoelectric generator module. Here I want to clear the thermoelectric device, it is nothing but not a big device. It's a simple biscuit shaped device. In the next slide, I put in the figure. Then here in the structure of thermoelectric generators, here is it consists of P type or N type of semiconductors, which is made up of different materials. And here the P type or N type of semiconductors which are metallically connected to each other. It's from the thermocouples or thermoelements. It is also known as the dies or pellets. In this way, the number of, if you see the picture, in that picture, number of the P type and N type of semiconductor is there. And all the thermocouples which are electrically connected to each other in a series and which is connected parallel to the thermal. Then here is the two lead wires there. One is the red wire and second is the black wire. Here it is the one acts as a negative terminal and one acts as a positive terminal. Then above this internal structure of this, one is the cold side and opposite is the hot side. Cold side acts as a hot absorber and hot side it acts as a heat releaser. And when this thermocouple is in contact with the hot sides and cold sides, this thermocouple it is sandwiched in between the two surfaces. Means one hot side is in contact with the hot surface and cold side is in contact with the cold surface. And due to this temperature difference and the movement of the electrons, it creates the voltage across this positive terminal and negative terminals. Here is the basic concept of the thermoelectric generator module. Same thing is here. In these pictures, the first one is the N type and P type of semiconductors which are metallically connected to each other. And in the second figure, the P type and N type of thermocouples or thermoelements, or you can say that the dies, which are electrically connected in a series. And this thermocouple or thermoelement which is made up of different materials. Which types of material used for the N type and P type of semiconductors we will see in the next slide. Then most important part is the geometrical parameters of the thermoelectric generator module. In the first picture, if you see the biscuit shaped device, it is nothing but the thermoelectric generator. And we know that the function of the thermoelectric generator is due to the temperature difference, it creates the voltage. And it is acts as one of the alternative source for the energy. Then, the performance of the thermoelectric generator, it is not only based on the material, it is depends on the geometrical parameters also. Then what are the geometrical parameters of the thermoelectric generators or TEG? Here the size, conventional size of the thermoelectric generators is 3 mm square to 4 mm thick, up to the 75 mm square to the 5 mm thickness. Here is the geometrical dimensions of the TEG module. Then lengthwise it's a 15 mm length and the height of the single stage thermoelectric module, it is in the range of 1 to 5 mm. These are the geometrical parameters of the thermoelectric modules. And then how we can select the size of the thermoelectric modules. The size of the thermoelectric modules, it is selected as per the applications. Means whatever
there will be effect of the temperature is not constant. Maybe the temperature is, I think, temperature does not constant. Maybe 350 through a full day or.
Then according to the temperature range, you can select the thermoelectric device.
Yes, okay.
Means in our experimentation, our requirement is about the 300 degrees Celsius. In that case, I am selecting the maximum temperature of the TEG is 300 degrees Celsius. Then according to your temperature difference, you can select the TEG module.
Thank you.
Anyone please?
आपने vehicular exhaust होता है तो उसका यूज करते फॉर इलेक्ट्रिसिटी प्रोडक्शन
उसका यूज के लिए हमने सोचा था कि इट इज यूज्ड एज द कोल्ड सोर्स फॉर द lubricant, so that the viscosity of the lubricant after heating the viscosity of the lubricant is changed or low. In that case, you are use that source as a means whatever the output obtained from the exhaust, you can use that output as a to the fan, and that fan effect is on the engine. Anyone? Okay. Thank you very much for your listening patience.
Okay, the seismology, engineering seismology, then how earthquake occurs, waves, different types of waves, their effects over the structures, and then lastly we'll see the smart materials. Okay, so thereafter we'll see the earthquakes and its causes, then seismic instruments and recorded ground motions and recorded ground motions we will be discussing. Then seismic effect on structures. Okay, how it is different than wind, that also we are going to see over there. Then what is the design philosophy? Then there are different mitigation practices. Mitigation means reduction in the earthquake response. So that is called as seismic mitigation techniques. We'll see that. Then smart materials, and then lastly the references. So now every day there are about 50 earthquakes that we felt, and few earthquakes they are capable enough to cause the damages in the structures, and these earthquakes they radiate seismic waves throughout the earth. Some are transferred, reflected, and what we can say they refracted at the surface, and these are mostly the dangerous, the severe waves as far as structure is concerned. Then seismology is the science that studies the waves. So what are these types of waves, their effects over the structure, what is the physics of earthquakes, then anatomy of structure, earth. Okay, what is the anatomy of earth? That also comes under the category of seismology. Then it is also directly concerned with the understanding of physical process that cause the earthquake. And as far as humanity is concerned, we have to reduce their impact. So earthquake will not kill the people. The bad structures which were not designed properly, they will kill the structure. Okay. The term seismology, it is derived from the Greek word. Seismo means shaking and logos means science or knowledge. Now, before to go into detail of seismology, let's talk about the past history of seismology that comes under Geological Survey of India. So, the first director is Dr. Thomas Oldham. He has prepared the catalog for Indian earthquake, and that preparation of catalog is after the Chachar earthquake. It is in 1869. Then thereafter his son R.D. Oldham contributed greatly in the investigation of Assam earthquake. This is one of the most dangerous earthquake in Indian seismology, we can see, because it is having the intensity 12, and 12 is the maximum intensity. It is total destruction of the structure. Okay, so he has investigated that earthquake, and whatever the investigations, whatever the report he has prepared, that has been used by the rector, rector scale. So that has been used by the rector in 1958 in one of the most popular book of engineering seismology. Then Oldham studied Kangra earthquake also. Then Bihar Nepal earthquake. These are also the major earthquakes in the Indian plate. Then Oldham in 1899 also discovered one of the major fault. Okay, that fault is called as Allahabad. So it is located in the run of Kutch region, Gujarat. It is 100 meter long, 3 meter high. Okay, so after then one of the significant contribution that I told that Assam earthquake, it is at the magnitude of 12 in modified Mercalli intensity scale. Okay, so which were used by the rector in his engineering seismology study. Right. Then for the first time, the Oldham has recognized the existence of longitudinal waves, thereafter these transverse waves and surface waves. Okay, and those were recorded in the seismograph, and thereby laid the foundation of modern seismology as far as Indian context is concerned. Then after Assam earthquake, the development of Assam type houses were started, and still in the entire northeast region, these Assam type houses, they are still built. Okay, they are lighthouse, low cost housing, we can say, and the impact, how it was started, it is after the Assam earthquake only. The first seismograph in India was installed in 1898 by Kolaba Observatory in Bombay. Okay, so there the first seismograph is installed. The first major initiatives for earthquake resistant design is started after Balochistan earthquake in 1930s, and one of the most significant person is S.L. Kumar. He has started the seismic coefficient method as per as Indian concept. You know that in IS 1893 the 3 or 4 methods, if you consider push-or analysis also, 3 methods are there: equivalent static analysis. Earlier it was called as seismic coefficient method. If you refer 1893 1984, it is given as seismic coefficient method. In 2002 1893 it has called as the equivalent static analysis. It is one and same thing, right? So the first foundation of that particular method was started by S.L. Kumar, young railway engineer who has contributed greatly on this seismic coefficient method, and he has prepared the map of country also. So here you can see one table. Okay, classes of building. So this was the seismic factors given by Kumar. Okay, in the 1930 era, right? So here you can see the violent earthquake, if it is there, A type building is monumental type building, historical type of building, important type of building. For the building which is 50 meter high, and B means all other types of building, right? So for violent earthquake, the seismic coefficients are given 0.15 G. Okay. Then for strong earthquake 0.1 G, for weak earthquake 0.05 G, and for rare earthquake it is not specified. Right? Now the first earthquake engineering institution was established in IIT Roorkee, so that information is given over there. So institution base for earthquake engineering was established around 1958, when after a visit to California Institute of Technology, because 1940 earthquake, Al Centro earthquake, most of you know that. So Al Centro, it is Northridge, Al Centro, these are the Californian earthquake. Okay, so in 1940, USA started the work on earthquake engineering, whereas as far as Indian context is concerned, we have Sir Jai Krishna, who was the recipient of Shanti Swarup Bhatnagar Award, Council of Scientific, Industrial and Research in 1966, then Padma Bhushan in 1972. He was the first person who has started this course in IIT Roorkee. Okay. And the most famous, what we can say, the symposium, okay, earthquake symposium is there. I think 13 symposium, just now 1 year before it has completed. So every 4 years there is a symposium. Okay, so that symposium is organized by IIT Roorkee from 1959 onward. Okay, then seismology is the study of generation, propagation and recording of elastic waves. Okay, so natural and man-made sources are there for earthquake. Earthquakes are caused because of these natural sources and man-made sources. So there you can see tectonic earthquakes are there, tectonic plate movement, volcanic eruption if takes place, then also that causes earthquake. Then collapse of cavity, sometimes sub-terrean region, they are having, we can say, the landslide type of thing. Okay, rock falls and then that also causes the earthquake. Then microseism. Then man-made sources are controlled sources, explosive. Okay, mining blast comes under this category. Then reservoir-induced earthquake, the one of the most famous earthquake, reservoir-induced earthquake is Koina earthquake, 1965. Then mining-induced earthquake. Then cultural noise, industry, traffic, that also cause the earthquake. Right, so about 90% of all these earthquakes are due to the tectonic plates, and that is over the fault rupture plane. Right, and tectonic earthquakes are triggered. What will happen in the tectonic earthquake? The convergent boundaries are there, divergent boundaries are there. Convergent means the plates are moving towards each other. So when that will happen, so because of that there is an accumulation of strain energy. And if that strain energy is beyond the shearing strength of rock, because rock will have some shearing strength, if it is beyond the shearing strength of rock, then suddenly it will fail and lot of enormous amount of energy is released. That we call it as earthquake, right? So these are the natural disasters: earthquake, tornado, floods, fires, then landslide, volcano, hurricane. Then damage caused by these natural disasters. So here the pie chart is given. So loss of life, human life from the natural disaster. Here you can see the, here you can see 55% people were killed during earthquake, and in flood 27%, hurricanes 11%, that in USA, and volcano also 3%. Right. Loss of built environment means the buildings were collapsed and this built environment has collapsed. It is lost due to natural disaster. There also you can see the contribution of earthquake. It is around 50%. Now this is what elastic rebound theory. The first time it was proposed by Reid, professor of geology at Johns Hopkins University, explained the earthquake, how it has occurred, what is elastic rebound hammer theory at the fault plane. So there is so here you can see the stress building will be there. Okay, there are two plates. One plate is moving, okay, in the, what we can say, leftward direction. This will move in the rightward direction. Right. So because of that, there is an strain building process, and okay, so here you can see the strain building will take place, and there is a deformation, and the rock will have the some permissible, or what we can say, the maximum shear strength. If that stress is beyond that permissible shear stress or maximum shear stress, then suddenly there is a rupture, there is a fail of that plate. So here you can see these lines were been mismatch. So because of the rupture it takes place. So just after the earthquake, the scenario will be something like this. So the same thing is explained here also. the accumulation of energy, the elastic stress will be developed, then suddenly there will be an earthquake, the total energy is lost, again the strain build-up will start, again second earthquake will take place, again strain build-up will be there, energy build-up will be there, and there is sudden release in energy. The same thing is explained with the help of these figures also. Okay, so if there are two plates and over the two plates H is there, so during no earthquake original position it will be like this, during deformation of the tectonic plate movement it will be something like this, and when the rupture takes place, the release of energy, that time it will be like this, and it will be as it is, and now this will be again the next, okay, this is for next instant, again the strain building process will be there, started, and the next earthquake will occur, right? So now let us talk about the earth anatomy. So around, what is the radius of earthquake? 6500 roughly, 6500 kilometer, isn't it? So that total radius, it has been distributed in these regions. So here you can see the inner core, okay, solid material, then outer core, that is also this solid material, then mantle, this is viscous material, correct, molten lava, it is there in this mantle, and crust. Crust means the earth surface, tectonic plates, they are just 5 to 70 kilometers. Okay, at some places the thickness of that plate is 5 kilometers, at some places thickness is around 70 kilometers. Okay, and their velocities, the shear wave velocities are given in kilometer per second for different regions, for inner region, for outer core, mantle, and for crust it is been given. That density is also mentioned here. As I said, inner core it is solid material, so here you can see the high amount of energy, high amount of density. Then again this is also having high amount of density, and this mantle and crust, mantle is having density high, but it is in the liquid state, whereas crust is in the solid state. Right? So the densities are given, it is in gram per cubic centimeter. Right? The source is IITK BMTPC earthquake tips, isn't it? IIT Kanpur, they have prepared it. Now convective currents circulation. What do you mean by convective? How these plates are moving? What is the reason behind the movement of this plate? So that has been explained over here. You can see the plates. Here there are the plates, tectonic plates, and there is a temperature difference at the crust as well as at the outer core. Okay, mantle it is the liquid state, but pressure gradient is there. Then the temperature difference is there. This is high temperature, here there is a low temperature. So because of that, what will happen? The convective currents will start. This you can see, beaker. Okay, and in beaker if you hit it, the water is there in the beaker. If you hit it, what will happen? Okay, some sort of ED's current you can see. Okay, ED's current. These are the ED's current. So there is a circulation, the ED's currents are there. So because of that, here you can see the plates are moving towards each other. Here somewhere the plates are moving away from them. So that will happen. Sorry, here it is moving towards, here it is moving away. Right. So the same thing is happening. And what happens in some plates are moving with slow velocity, some plates are moving high velocity. So because of that, because this temperature gradient, it is not been constant. Okay, for the entire earth circle, that at one location temperature gradient will be different, temperature pressure difference will be different, right? So that's why their velocities of plates will be different. So what will happen if slower velocity is there of a plate, and on the rear side there is one more plate that is moving with fast velocity, so there will be a chances of collision. Okay, and if it is collided, then earthquakes or mountains are formed. Mountains are formed, you know that. And when they are divergent boundaries, okay, at some places divergent boundaries are there. So at divergent boundaries, that is rift. At rift or ridges, the volcanic eruption will take place, right? Now what do you mean by earthquakes and its causes? So vibration of earth's surface caused by waves originating from the source of disturbance in the earth mass is called as earthquake. Then the earthquakes are caused because of volcanic eruption and tectonic plate movements. So these are highly unpredictable. Then plate tectonics. The convective flows, as we have seen earlier, the convective flows of mantle material cause the crust and some portion of mantle. Okay, crust means that uppermost layer of Earth's surface, along with some mantle portion. They are moving with the hot molten outer layer, outer core. The sliding of Earth's mass takes place in place of tectonic plate. Now here you can see there are 7 major tectonic plates. These are the 7 major tectonic plates. Okay, Eurasian plate, then Indo-Australian plate, Pacific plate, North American plate, South American plate, African plate. Okay, and on this side also Philippines plate. So likewise there are several plates are there. Some minor plates are also there, like Caribbean and those. Okay, that we'll see. So now here New Zealand, you know this New Zealand, right? Now I think 1 year before, the scientists have discovered one land over here, what we can say, continent. One continent they have discovered. They are calling it as Zealand continent. Zealand continent. It is very big. Okay, it is very big. So I think this tectonic plate maps may also get changed. Okay, may also, because that has discovered recently. Here somewhere. Okay. So now, as I explained, these are the convergent boundaries. So what happened here? This plate, okay, this plate is moving slower. This plate is moving higher. So one plate is having a maximum density, another plate is having lower density. So what will happen? The maximum density will stay as it is. Lower density will move in the oceanian plate. Okay. So these are the continental plates, and there below that there is an oceanian plate. So this plate will go into the oceanian plate, into the what we can say the mantle. Okay, this will go into the mantle, and here the mountains are formed. So this is what convergent boundaries. Then divergent boundaries. So here volcanic eruption will take place. They will move away to each other. They will move here. They will move towards each other. Here it will be away from each other. Now sometimes there will be transverse boundaries also. Okay, transverse boundaries, isn't it? So this is very common. This is one of the most famous fault on the transverse boundary is San Andreas fault. San Andreas fault in USA. Okay, that is transverse boundary. Okay, the plates are moving. Both plates are moving in the same direction, or sometimes plates will move opposite to each other, like shear. Okay, like shear, it will be there. Okay, now here this figure, I think Bacchus has also shown the same figure. So it is the work of D. Matos and other authors. They have given how much that plate is moving. Okay, the convergent boundaries, divergent boundaries and transverse boundaries, how they are moving in mm per year. So that here you can see in Himalayan region, somewhere here, 48 mm per year. Okay, 48 mm per year. This is what the convergent boundaries. Okay, convergent boundaries. This indicates the convergent boundary. Then this is what the spreading boundaries, that is divergent boundaries. Divergent boundaries are here. You can see divergent boundaries. And transverse boundaries here, as I said, this is what San Andreas fault. Okay, this is one of the major, the California region, California earthquakes occur because of this fault. Okay. Now, where do earthquakes occur and how often? 95% of earthquakes are occur because of plate boundaries, and more the convergent margin activity that is responsible for that. The remaining 5% occur in the interior of the plate. There are two types of earthquakes. Okay, interplate and intraplate. Okay, interplate means they are because of convergent boundaries. And intraplate म्हणजे जे बाउंड्रीवर होतात, जे बाउंड्रीवर आहे हे दाखवलेले आहे. Here you can see हे बाउंड्रीवरचे जे earthquakes आहे they are called as interplate earthquakes, and intraplate means Latur earthquakes and okay, Koina earthquake, ते intraplate boundaries आहे. Okay, आणि जे boundaries वर होतात they are the what we can say the interplate earthquake. Then properties of plate tectonic theory. The continental crust is less dense. There are two types of plates, continental plate and oceanian plate. So continental plate crust is less dense and lighter than the oceanian plate, and that's why it sinks easily. It never destroys and neither be temporary. It is permanent. Oceanian crust is heavier, so it can sink below the continental crust because mantle it is the liquid part. So that if it is having less density, that can float. If it is having more density, that will sunk. Okay, so oceanian crust it is having the high density, that's why it is been sunk. It is constantly being formed, destroyed at oceanian region trenches. The continental crust can carry on beyond the edges of the land. Also, continental crust आहे हा land वर असू शकतो, or it may be inside of the ocean also. Okay. Then plates can never overlap. A plate कधीही एकमेकांना overlap होऊ शकत नाही. So what will happen? One plate will move down, another will be move up. Okay, it is like that. Then there can never be gap between the plate. Okay, there can never be a gap between plate. म्हणजे समजा if the divergent boundary is there, so that gap is immediately filled by other volcanic rock, basalt, okay, it is immediately been filled. Okay, then Earth is not getting bigger or smaller. असं तर होत नाही की Earthचं diameter कमी होत आहे जास्त होत आहे. So what is the reason? So that means the amount of new crust is being formed. It is same as that of amount is being destroyed. जेवढा destroy झाली plate तेवढीच कुठेतरी ती form झालेली आहे. So plate movement is very slow. Nobody could see the continents moving. When the plates will suddenly move, that we call it as earthquake, and that times we felt. बाकी अजून आताही सध्या आपण ज्या ठिकाणी आहे पण अजूनही टेक्टोनिक मुवमेंट होत आहे, अजूनही टेक्टोनिक मुवमेंट होत आहे. But that tectonic movement is very means you cannot felt easily. But if you are having the recording instrument like seismograph, accelegraph, there you can record. Okay. So this already been discussed. So the energy release during Bhuj earthquake, it is 400 times that the energy released by 1945 atom bomb drop over the Hiroshima. This is important. So the Bhuj earthquake, it is 7.1 Richter scale. Okay, it is 400 times more stronger than the atom bomb which was dropped over the Hiroshima. Then types of earthquakes and faults. So there are two types majorly. Deep slip fault. This is deep slip fault. Okay. And another is strike slip. Okay. When there is a transform boundary is there, this fault it is called as strike slip fault. Whereas in the convergent or divergent boundaries, this is deep slip fault. It is not like that. Okay, here you can see interplate earthquake. The Assam earthquake, we can say it is interplate. It is over the plate boundaries, tectonic plate boundaries. If it is over the tectonic plate boundaries, that is called as interplate earthquake. If it is inside the plate boundaries, it is called as intraplate earthquake. Intraplate earthquake, like Latur earthquake or Koina earthquake, we can say. So these are some images of the faults. Minor faults in Bhuj earthquake, then Chichi earthquake of Taiwan. So this is a very devastating earthquake. You can see the total upliftment of the road over here, and okay, this is what the fault rupture, and here the river path is completely changed. This is what the dam. Okay, dam. path is completely changed. This part is lifted up, this part is moving down. Okay. Then there are some terminologies involved in earthquake engineering. What do you mean by epicenter? So rupture will take place here. This is called as focus, where the actual earthquake happens, where the actual energy is released. That is called as focus. Then epicenter, exactly about that. Okay, in vertical direction or radial direction towards the earth. If you draw a line from this point towards the center of the earth, and you can extend it over the surface. So over the surface you will get the epicenter. Then this is what the focal depth. Then the place of, now here you are measuring that ground motion. Ground motion is measured here. So epicentral distance. Okay. The seismograph or accelegraph, they are being here. So here you are measuring it. So epicentral distance has been measured from that point towards the epicenter. Right. So here you can see the waves. Okay, primary waves, secondary waves, surface waves. Okay, so there are two types of major waves, body waves and surface waves. The body waves, again it has been, it consists of two types, that is primary waves and secondary waves. Surface waves, it has been divided into two types, that is love waves and release waves. Under primary waves, the material undergoes into larger. Now primary waves, they are only the compressional or what we can say the extension, or tension or compression, right? Okay, and then the secondary waves, they are right angle to that. With the help of this figure, actually it has been very easy. This is primary waves, they are either push or pull only, push or pull. Now secondary waves, they are in the vertical direction, up and down, up and down. These are the body waves. These are the body waves. These are the surface waves. Surface waves are love waves. Now this love waves, it is over the horizontal plane. It is side sway in horizontal plane. Here, horizontal plane la asa hota hai. It is like this. Okay, it is like this. Then release wave, it is elliptical in vertical plane. Okay, yes wave जो है, it is not elliptical, it is square. ये तो तुम लोग जानते हैं, ये element है square. Here it is elliptical. Okay, it is elliptical. Then release waves, it is in the vertical plane. Love waves, it is in the horizontal plane. It is on the horizontal plane. And this is what the body waves are here. These are the body waves. These are the surface waves. Okay, structure. The structure is damaged because of surface waves. Okay, surface waves are responsible for the damage of the structure. Now P waves are faster. Thereafter secondary waves, primary waves are faster, secondary waves thereafter. Then surface waves, they are a little bit slower compared to the primary waves and secondary waves. The primary waves speed is around 4.8 km per second, and the secondary waves, it is having the speed, velocity, okay, shear wave velocity we can say, it is 3 km per second. And one of the most important is the secondary waves, they do not travel through the liquid. They do not travel through the liquid. The secondary waves in association with the effect of love waves, that is the surface wave, cause the maximum damage to the structure, that is racking motion on the surface of the earth. So vertical and horizontal direction will be there. Okay, so then shaking is more severe, about twice as much as earth's surface than the substance. Okay, now here, the waves are the shaking you can, surface waves are predominant, they are disturbing. But if you want to design the structures below the ground, okay, below the ground, that is to be designed with less acceleration. The buried structure, underground structure, they are having the less acceleration compared to the surface acceleration. Surface having the major acceleration, but buried structure, underground structure, there the accelerations demand is low. Now this is the seismic instruments and recorded ground motion. Now how these waves are recorded? Okay, so there you can see one of the most famous earthquake recorded. It is in China, Cheng Hong earthquake weather rock. It is I think 138 AD. Okay, the person who had developed is Cheng Hong in 138 AD. किती वर्ष झाले? जवळपास 2000 वर्ष झालेले आहे. 2000 वर्षापूर्वी त्यांनी काय केलेलं होतं की इथे कंटेनर आहे, इथे हे ड्रॅगन आहे, 8 ड्रॅगन आहे 8 डायरेक्शनला, आणि ह्या ड्रॅगनच्या माउथ मध्ये एक बॉल ठेवलेला असतो. इथे एक बॉल राहायचा. इथे हे जे आहे दीज आर दी टॉड्स, जे फ्रॉग. ओके, बरोबर याच्या एक्झॅक्टली खाली आहे ते असे 8 फ्रॉग आहे, आणि याच्या आतमध्ये देयर इज अ रिव्हर्स पेंडुलम. ओके, देयर इज अ पेंडुलम. When earthquake occurs, the pendulum will swing. Pendulum will swing, and हे जे ड्रॅगन आहे याला 8 प्लेट आहे आतमध्ये, आणि स्विंग होत असताना तो काय करतो, त्या प्लेटला टच करतो. ओके, त्याच्या प्लेट्स आहे 8 प्लेट आहे, त्या 8 प्लेटला कुठेतरी तो टच करेल. इट इज लाईक दिस, टू अँड फ्रो, टू अँड फ्रो, सो फ्रो टू अँड फ्रो, so then it will touch to that plate. When it touches to that plate, what will happen? The ball which was there in the mouth of this dragon, it has been released. Okay, it has been released because of that touching. When it touched, that ball is released and it has been collected over the toes. Okay, इथे तो कलेक्ट केला जातो. मग याच्यावरून आपल्याला काय मिळतं? याच्यावरून you will get the direction of earthquake. ओके, डायरेक्टली म्हणजे कुठल्या वेव्स जे आले, कुठल्या डायरेक्शनने आले, ती फक्त डायरेक्शन इथे मेजर केली आहे. ओके, किती अमाउंटचं ऍक्सेलरेशन आहे वगैरे, दॅट इज नॉट बीन रिकॉर्डेड. दॅट टाइम डायरेक्शन इज ओनली रिकॉर्डेड. So now there are 2 types of instruments: seismograph. Okay, then seismogram, it is actually a record. This is seismograph is an instrument. This seismograph, it is sensitive and less accurate. Sensitive आहे, but it is less accurate. Then accelerogram, it is also the instrument nowadays because of the analog instruments and digitalization, smart computers and so on. Now people are preferred to use this accelerogram. It is also an instrument. Accelerogram is a record. Okay, and it is more accurate but less sensitive. Now in this seismograph there are 3 things. One is sensor, second one is recorder, and one is the timer. That we can see over the next slide. ह्या 3 गोष्टी आहे: sensor, recorder and then timer. Okay, now here this is what the earlier seismograph, this was developed by Charles Richter. Okay, around 1930. So here there is a string and then bob. At the lower end of the string there is a bob. Here it is hinge, then pin attached to that. Here there is a magnet to control the oscillation of the string. Then there is a rotating drum which is moving with some constant speed, constant RPM. It is moving, this rotating drum. Then when the shaking will start, that pin will mark the shaking or the drum. It is something like this. This is what the direction of earthquake. Okay, and then you will get the seismogram. This is seismograph, and this record, also record meter, this is called as seismogram. Right? So pen is attached at the tip of an oscillating simple pendulum, which is a string, makes a chart paper that is held over the drum, rotating with some constant speed, with some RPM. Then magnet around, this magnet is just to control the oscillations. Okay, if it is beyond, actually. And a jhola for infant, that is there. Then it is a roping system, then it is a ladder, and last one is the, what you can say, ladder, which is normally used to carry the dead bodies. And all these things are possible with bamboo. So today we are going to target only one material, that is bamboo. Not as a farmer, as an engineer, as a civil engineer, how we can utilize bamboo. So it can be used for the tripod, for that jhola, then for shelter system,
for your ladder of success and for your last journey too. Khalchana, pray. This is the bamboo tunnel. It is about 650 meters and it is in my institute. And I am lucky that I was part of this plantation in 1987. असा हा बांबू टनेल 600 मीटरचा आहे आणि याच्यातूनच यावं लागतं. याच्यातून मुलं आली एकदा, त्याचे पालक आले की तो परत जायचं म्हणत नाही. नंतर ओरलच्या वेळेस मुलाला समजतं की चूक झाली. पण दिस द बांबू टनेल. नाउ since it is planted in 1987, that I'll tell you right now, life of bamboo is 35 to 40 years, and now some of the bamboos, they are dying. They are at dying stage. Replantation will be there. Now you are familiar with these facts. India at a glance. We are now 135 crore plus. And the second I am marking red because that may not be correct. We may be the first. Number of villages in India, there are 7 lakhs. Shortage of houses is 200 lakh units. This is the shortage. And this is horizontal figure as far as civil engineering is concerned. And 136 lakhs units, that is 75% of the total, is shortage in rural area. Government have introduced a national housing policy, but somehow that is not worked properly, or it is not succeed because of large capital investment and the land problems. Now, what is low cost housing? Low cost housing, name is self-indicatory where the cost is low. But how the low cost is achieved or how the cost is optimized, कमीत कमी कसं केलं जाईल, कॉस्टिंग, त्याच्यासाठी न्यू मटेरियल, न्यू टेक्निक्स. This is all related to civil engineers. Locally available material and labor, utilizing waste product and from the industries which we have utilized, and all these things, they must be without compromising the safety and serviceability. Safety and serviceability. All of you are knowing, are familiar with IS 456, in which safety and serviceability, both the criteria, they are the must. And the low cost housing in developing countries, again the same proper utilization of resources. Then income level, it depends upon the income level. Then cost of the building material and cost of the labor. Now how to achieve this? This part I am going to cover in due slides, so I will skip this slide. This is housing for urban poor. It's not like that ki the poor, they are only in villages. There are very large percentage of population staying in urban areas and they are poor. For that, cluster development is one of the things. Cluster, you have heard this. Nowadays teachers are listening this word cluster every now and then. Cluster universities. समझ ना, cluster universities. Now we are famous for very good things, very bad things also. We are knowing that Dharavi is the biggest slum in Asia. Biggest slum. This is not a matter of pride. Then what is cluster? This Dharavi Jhopadpatti, they are using only single story or two story structures. And they are utilizing very large, about 236 hectare of land. 236 hectare. 236 hectare of Dharavi. And what do you mean by cluster? Cluster says that you demolish all these slums and you go for multi-story structure and vacate the land. And on these land there will be proper parking arrangement, proper community halls, proper clubhouse, Nana Nani park, garden, hospital, everything. And all these people, they can be accommodated in high-rise buildings. That is called as cluster. How it is? Parallel to universities. So we are going to form universities with engineering, pharmacy, then art, commerce, science, like that. So this clustering will be there. So high-rise building containing small apartments, they will be there. I am from very poor background. My father was farmer, and when I got engineering degree, my father, who was only learned up to second class, he said, I learned that you are going for research at all that. So he said कि गरिबांसाठी काय करता आलं तर कर. So scientists, they are working for classes. Most of the scientific research, they are for elevating the lifestyle of the richer people. But I have thought that I will work for masses, poor people, downtrodden people. And for that, I have not thought over this, but I have concentrated on rural poor. Now, how to achieve low cost? Now, houses in rural area, you are aware of this. There are so many slides, so I'll skip some of the slides. Now, sustainable development. One socialist said की माणसासारखा हलकट प्राणी या जगात पृथ्वीवर जन्मलेला नाही. माणसासारखा means there is no limit to its greed. माणसाची हाव आहे, त्याला काही लिमिट नाही, म्हणून तो हलकट प्राणी आहे. इतर प्राणी त्यांचं पोट भरलं की ते खाणं थांबवतात, आम्ही थांबवत नाही. म्हणून सस्टेनेबल डेव्हलपमेंट म्हणजे काय? मग आम्ही ओरडायचं आमची गोदामाई आहे, आमची प्रवरामाई आहे, आमची गंगामाई आहे. बट वी हॅव स्क्रॅप द सँड लाईक एनिथिंग, आणि आम्ही एक वाळूचा कण सुद्धा ठेवला आहे. सस्टेनेबल डेव्हलपमेंट म्हणजे काय की प्रोग्रेस ऑफ प्रेझेंट जनरेशन preserving natural resources for further generation. बराबर? Progress. Every generation must progress, but there should be natural resources for the next generations, not only next generation. नाहीतर मग मी सारी वाळू वापरी आणि पुढच्या जनरेशनला वाळू चित्रात दाखवावं लागेल. उसको दिखाना पड़ेगा इसको सैंड कहते हैं. नाहीतर मग काहीच राहणार नाही, सगळं मी वापरून टाकेल. मग हळूहळू माझी पोरं जंगलाकडे जातील परत. हो चला ताजन बनू, असं ते नाही का हो करत राहतो ताजन. सो नॅचरल रिसोर्सेस मस्ट बी प्रिझर्व्ड. Now here comes our role. Role of civil engineering, civil engineers. Energy efficient planning of building means the building which requires minimum energy for its construction and for its life, throughout the life. तो लॅपटॉप तिकडे ठेवता येईल का? मला असं एका जागी उभं राहून शिकवायची सवय आहे.
खाली आहे
याच्यावर ठेवता येईल का? ते त्याच्यामुळे अडत आहे. That way, I am very Khadush teacher. I use more Khadu. That's what. And I used to go to students and beat them if they are not attentive. इथं काय तसं मारणार नाही.
ठीक आहे. तिकडं आपलं खालच्या
झालं. Okay. Next is energy efficient material. Then use of energy efficient techniques. These we will see one by one. Then use of local labors and use of locally available material. Then rehabilitation, punarvasan. Now, energy efficient planning. We engineers are well aware of aspects and prospects, 10 principles of planning. And that is, major is aspect and prospect, that is orientation of units. In that, sometimes this Vastu Shastra is helpful, sometimes Vastu Shastra becomes harder. So, that Vastu Shastra is there, orientation of units means where should be the living room, where should be the bedrooms, kitchens and all that. And major concentration as far as running cost of the structure is concerned, then there should be opening, proper consideration given to the opening, size of doors and windows, their locations, their orientations and their shape, so as to use maximum natural resources, that is light and air. Then energy efficient material. Which are the energy efficient material? You might be knowing some of them, and I will add some in that. Fly ash and rejected coal bricks. You are aware, most of you are knowing that thermal power station. There, the fly ash containing reactive silica is used for PPC cements. You are aware that all the PPC cements, they are containing fly ash. And how much is the percentage allowed by IS code?
30 to 40?
21%. And at present, all the cements, they are using 17%. They are blending 17% fly ash. But this is the fly ash which is having higher reactive silica, which is used for secondary hydration in cement. Fly ash is there, and that fly ash can be used even when the coal is being burned. When the size degrades by burning, then there will be screens, and after some 10-15 minutes that screen shivers and the small pieces of coal they fall down. That is used for bricks. Then fly ash in mortars. When we go for brickwork, even most of you are knowing that brickwork can be done in mud mortar also. Instead of using mud mortar, you utilize some then use of glass PPC cement that we have already talked. Then about door and windows frame. Door window frame, most of us are knowing that they are of wood and all that. But when we expect wood, then there will be great harm to the nature. For that, you can go for pre-tensioned concrete frames, and they are very good. In my own house, I have used that pre-tensioned concrete frame. Even in 700, 800 rupees, you can get it, and with best quality. In Maharashtra, the low quality production is there, but from Gujarat, we are receiving better quality pre-tension products, and that can be used, and there you can save like anything. Then use of rejected lime. You are knowing that while producing sugar, they are using lime at very heavy quantity, and there also you are getting rejected lime. This rejected lime you can use for brickwork. Then today's topic, that is substitute reinforcement. Friends, I told you in the starting that I am going to talk on bamboo reinforcement. People will say, oh, we are getting steel, and why he is thinking of bamboo reinforcement? Think globally. Think the poor countries. Burundi, Rwanda, Ethiopia, even Sri Lanka now, some days before Bangladesh. In these countries, if a person works for a day, a layman, he can't purchase a single kilo of steel. येते लक्षात? सामान्य माणूस जेव्हा काम करतो या देशांनी, तर तो संध्याकाळी 1 किलो स्टील घेऊ शकत नाही. In our country, when a person works, he can purchase 4-5 kilo of steel. This is our goodness of our country. But in some countries, steel is really a luxury item for them. Then one has to think of substitute reinforcement. And how steel is manufactured? It is manufactured from ore, iron ore. And iron ore, the stocks of iron ore, they are depleting like anything, day by day. दरवर्षी ते कमी होत आहे. And the developed countries like US, they are purchasing the iron ore from poor African countries, even from China. Even we are importing, though we are saying that China is our enemy, we are using some products, steel products from China. So one has to go for alternative material, otherwise there would not be virgin steel after some years. Just read this quote and tell me if you are able to ascertain whose quote is this. God has gifted everything, within the radius of 10 kilometers to cater the need of human being, including food, clothing and shelter. It is by our Rashtrapita, Mahatma Gandhi. Mahatma Gandhi said that God has created everything to cater the need, not the greed. Greed has no limits. Now our target. Target bamboo. Bamboo is a grass, not a tree. Up to 2018, see the mockery. Up to 2018, Government Forest Department was treating bamboo as a tree. Though in all literature it was grass, it was a tree. And they have banned the transportation of bamboo without government permission. It may be your own bamboo, cultivated in your own farm. They were not allowed. Nowadays they have changed that word and now you can transport bamboo from any place to other place without taking permission from Forest Department. And now uses of bamboo, that all uses you are knowing, bamboo can be used as food, rare pillar. Northeastern states and even whole China is using bamboo shoots for eating. आपण पण इथं नाशिकमध्ये पण बांबूचं लोणचं वगैरे भेटतं, माहिती आहे तुम्हाला? इट्स व्हेरी हेल्दी. बांबू शूट्स, बांबूचे जे कोंब आहेत त्याची भाजी आणि त्याचं लोणचं हे फार स्ट्रॉंग मानलं जातं. मी खाल्लेलं आहे. नंतर म्युझिकल इन्स्ट्रुमेंट, फार्म इम्प्लिमेंट्स, इवन वेपन्स, आर्चरी, देन रिक्रिएशन, toys, medicines, charcoal, fuel, flooring, plywood, scaffolding and other materials. Scaffolding you are knowing, building material you are knowing. But bamboo food is very good. And almost this northeastern countries and China, there the total trade of bamboo is generating, in China the trade of bamboo shoots in food is about 7%. And China is supplying bamboo shoots to rest of the world. Then it's very funny plant. Normally that shoots come out in month of May, and by October it will achieve its total height. 3 महीन्यात तो पूर्ण वाढता, 3 महीने में पूरा बढ़ जाता है. And remaining 3 years it will take to strengthen it. म्हणजे हाईट पहिल्यांदा वाढून जाते. तुम्ही ऊस पाहिला असेल सर्वांनी, यू आर सीन शुगर केन, बट वेन वॉटर शॉर्टेज इज देअर देन द नोड्स ऑफ शुगर केन आर व्हेरी क्लोज टू इच अदर. दॅट डोंट हॅपन विथ बांबू. बांबू हे स्वार्थी पीक आहे, व्हेरी सेल्फिश. फ्रॉम मे टू ऑक्टोबर देर विल बी रेनिंग, देर वोंट बी शॉर्टेज ऑफ वॉटर, and within that period it will go up to 30 feet, 40 feet, whatever feet it want to, depending upon the species. जैसी जात असेल तशी. And remaining it get matures within 3 years. Then you are knowing short column theory. Short column theory means the effective length should not be greater than 12 times the least lateral dimension. है ना? Then आता है 4, 5, 6. तर that theory is derived from bamboo. बांबूने आपल्याला ते सांगितलेलं आहे. डायमीटर त्याच्या 12 पट त्याच्या इंटरनोड मधले अंतर असते. Then hollow circular structure having diaphragms at regular level means the nodes. Hollow circular structure you are knowing. What is the speciality of hollow circular structure? Hollow circular structure, नाही माहिती? Civil engineers, structural engineers, the speciality of hollow circular structure is maximum moment of inertia per square unit of area. Highest radius of gyration. Radius of gyration तो माहिती है ना? Radius of gyration is imaginary radius which assumes that all the area is concentrated at periphery. And hollow structures are having maximum radius of gyration, And radius of gyration is the element which decides whether to buckle or not. मला काही पट्टी आणून द्या रे मध्ये. पट्टी लहान असली तरी चालेल. So maximum radius of gyration. यामध्ये एखाद्या ले लो ना, नींद नहीं आएगी. दे एकदा, मी थांबतो थोडा वेळ. एवढंच टाका. एवढ्या लवकर कशाला आणलं पण? एवढ्या लवकर नाही झोपणार. माझा आवाज सांगा. चहा पिता पिता सांगतो. एक संस्कृतचा प्राध्यापक होता आणि त्यांनी असं मुलांना विचारलं, आप सुन रहे क्या? ये संस्कृत का टीचर था. उन्होंने बच्चों को पूछा, बोलो बच्चों, माँ बड़ी कि टीचर बड़ा है? तो लड़कियों के साइड में देखा तो लड़की माँ बड़ी है, माँ बड़ी, वो हमें जन्म देती है. बॉयज की तरफ देखा तो बॉयज बोले माँ बड़ी है, हमें जन्म देती है. लेकिन वो जो लास्ट में बैठे हैं, कोई तो लास्ट में एक राउडी लड़का बैठा था, वो बोला टीचर बड़ा है, सबसे बड़ा टीचर, माँ से बड़ा टीचर. तो टीचर बोला कितना होनहार लड़का है, टीचर को माँ से बड़ा बोलता. बोलो बेटे क्यों? हाँ नहीं, बेटा बोला जब मेरी माँ लोरी गाती थी मैं अकेला सो जाता था, जब आप पढ़ाते थे हम साथ के साथ सो जाते. जो लास्ट में बैठते मेरा ज्यादा ध्यान देते हैं उन पर. माझं PhD झाल्यानंतर मला या ॲडमिनिस्ट्रेशन मध्ये ढकलल्यामुळे मला शिकवायला भेटत नाही. पण मग माझी मुलं जी आहेत ती इलेक्टिव्ह वगैरे घेतला तर म्हणजे ते बिचारे 6-7 तास बसून राहतात. म्हणजे मी कदाचित अजून चांगलं शिकवत असावं. Now see these last 2 points. हे शेवटचे 2 points आहे बघा. It is strong at par with mild steel. Mild steel तुम्हाला माहिती आहे सर्वांना, Fe250. Fe250, Fe means ferrous material and 250 is yield strength of that material, yield strength. And I'll show you after some time. Before that I'll tell you कि normal bamboo without node, Indian bamboo species have given highest 292. For mild steel it is 250. For Indian bamboo it is 292. And for Brazilian bamboo, Guadua, name variety Guadua, Gauda, Guadua, it have given 372. But problem with bamboo is that we can't use it without that nodes. Node येणारच ना प्रत्येक ठिकाणी. That nodes are unavoidable. So here we are getting the strength at par with mild steel. And you are knowing that before 1978, all the structure constructed, they were using mild steel as tension reinforcement. After 1972, tar bar came. And tar bar, they last long from 1972 to 2009. Now, in 2009, tar bar production have stopped. Now, we are using which bars? TMT. HYSD, that is there. High strength bar, tar bar, TMT bar, both are called HYSD bar. but tar bar are not now manufactured. And strength to weight ratio means 1 kg of bamboo and 1 kg of steel. The bamboo.
I will see from this area, okay? So I think it's visible to you. Responsible consumption and production, the climate action. So this is the major areas where our organization is directly impacting to our world and the future generations. So before starting the engines, just as we will have a glimpse on the materials. We know the materials having a different classes, like metals are there, ceramics are there, polymers are there, glasses are there, elastomers are there, hybrids are there. You people are more expert than me into that field actually. So this is only a glimpse of that. So these are the different properties, the mechanical, thermal, electrical, which is deciding what material to use to our applications and our products. So going into little details, like metals are there, ceramics are there, polymers are there. So mostly in an engine, most of the material in some of the waveform we are using. You must be remembering this photo now. This is the periodic table. This is the base of our knowledge and education. So this is linked to that. This slide shows the fundamental properties. What is being seen by our design, R&D and these things while developing a new engine or any new technology. That is the strength of the product. What material will give the strength? The strength is having a different nature, like elastic strength, some plastic, when it will deform. If you see, the assembly is the major operation in our area. Assembly, the torquing process is being used majorly. Torquing process. So torquing, if you see, we are joining two metal bases with some force and acceleration action. So that is giving some deformation to the product. So that deformation should be retained with that elastic modulus. If it goes beyond that, so it will have a plastic deformation and the material will not last long. Some problems will start coming in our engines and products. So that much of knowledge is very much required whenever you have started designing something. Similarly, the stiffness, ductility, hardness, corrosion resistance, timely as per the application it will change the selection of this. Again, some few more properties are there like fatigue resistance, conductivity, creep resistance, impact resistance, density and temperature tolerance. If you see the engine, it is a hot object because engines are having different categories. Let me explain into that. The internal combustion, external combustion, some different types of generator sets engines are also there, which are using different fuels. But mostly these engines are getting heated up. So heat conductivity is a different science which is mostly being thought while designing the engines. So it should easily carry the heat away from the internal burning chambers. So in that the material selection plays a major role. And other properties are also there. Let me move to material properties. The material, like the general parameters are like weight and the expenses. You must be knowing that you have heard that in Mahindra engines are little bit rigid engines. So if you see some vehicle is going on the road, you must be saying that instead of 4 people they are carrying like 18 people, 20 people. The engine is so powered. So we are having some calculations for making the design robust. So we are always thinking in the positive side. So that, but again, it is in reverse way increasing the cost of the vehicle. So anyhow, so the decision is a mixed kind of. Anybody will tell that cost come karo. But again, the decision will be based on the market actual conditions, what the people prefer in our local markets. So but the weight, whether we should use a cast iron, whether we should use aluminium, whether we should use something different material, that is depend on all the calculations. So there is not a single formula for anything to select. There are many background calculations are there. Because of that only we can select a pair and we can go ahead with that. Anybody can stop me at any point of time, because I don't want this is to be flowing from my side. The interaction should happen, otherwise बोलते ना मुझे भी नहीं समझ में आ रहा है कि वो ध्यान में नहीं आ रहा. So that is we should understand. You can ask at any point of time. The mechanical we already discussed, the thermal coefficient, electrical. So these are the 3 parameters like material, shapes and processes which decides which inclusively decide the product, what will be the product look like, what material it should be, what processes it should be. If somebody tells we want a heavy object with certain weight, which should do some toughness, it should have some toughness. So then we will see what manufacturing process we should use to make that object. So based on that only it will be decided. If it is a plastic object, molding will be there. If it is a cast iron object, casting will be there. If it is a strong, heavy cast iron steel is there, so steel material is there. Then it may be a forging, it may be a rolling. This kind of processes it will be decided upon. Again, the shapes. Whenever we see some shapes, it is not necessary it will be made by only one process. Some processes can be having some disadvantages also, some restrictions also. Like in the machining, lathe machine is the mother of all the machines. So in almost all the worlds of the process, 50% of the metal cutting is happening in the turning only. So that normally people think of the cylindrical object thing, not of the square object. Square is very difficult to make also. So that kind of decisions is based on these three topics. This is the base of that. One example, like while designing the cylinder block, if you want to design cylinder block, first we have to decide how much power it should carry, what segment we are looking for. Based on that, you will select its material. Let us suppose we need a huge power. So small aluminum engine, yes, currently we are having some alloys also, but it is not necessary it will deliver the bigger power. So we need some hardest material. So hardest material is what? If we go into deep, then you will find some material structures are there, some properties are there. You must be knowing about the cast iron. Na? So can I ask you questions in between? Is it okay? Na? कोई problem नहीं ना? तो थोड़ा सा interaction बढ़ेगा. So can anybody tell me what is the use of modular cast iron base? What is the usage of that? Is it for the toughness, or is it for the stiffness, or is it for the hardness? Can anybody tell? Modular cast iron I am asking.
Hardness.
Or hardness. Okay. Softness. It is for the dampening. That the nodules are there, you are right. So that nodes, if you go in the detail, the micro structure of that, you will find there are graphite flakes are different and straight flakes are there, which we call as the malleable, and this different cast iron graphite flakes, and nodular cast iron having a round shaped structures, which is creating a space in between. When some external loads act upon it, a bump, other guiding जोर से bump आया, so that it absorbs the mechanical vibrations forces, and it acts as a soft dampener. So such kind of selection is being done, looking at the microstructures, and then the quality also comes in the picture while selecting that. So whether we can make that modular easily, or we can make the graphite easily. If somebody tells, अरे वो अच्छा होता है लेकिन ठीक है, लेकिन वो बनने में कितना तकलीफ देता है. So then we have to select, it is having some problem, so we can go with this process, but we need to make it more factor of safety. So in that reverse way also we can do that. So this is one example. Now let us move to the engines. Can somebody explain what is going on this 1, 2, 3, 4 number? Different strokes are going on. So it is a cross section of a single cylinder engine. You are seeing this piston is going up and down. The piston is the middle part. It is the heart. It is the heart of the engine. Then after that you are seeing the spark is happening. Some valves are operating. So this is the science behind the internal combustion engine. Mostly I will talk about internal only. External, actually there is a different scope. So these parts are designed. The history is that in I think it is around 1850s, Rudolf Diesel, and you must be knowing Otto. These people have developed the engine at that point of time. Slowly, technologically, it is getting upgraded. Now the latest technological engine has been done. So different material is getting changed frequently. Earlier there was a use of strong base materials which was available in the market. But now the fine tuning, fine machining, and these things are going on. So it is getting upgraded timely. So we will discuss about these internal parts, their material selection, what we have selected into that. आपको कोई डाउट है तो यू कैन आस्क मी एट वन ना, तो थोड़ा सा ये रहेगा. You know the location of engine in the vehicle, na? Some vehicle is, majorly vehicles is having a front side engine. Some vehicle is having back side engine. It depends, मतलब ट्रक है कि vehicle है, ये different उसके हिसाब से रहता है. नैनो इंजन कहाँ पे रहता है नैनो का? ऐसा तो नहीं कि ऊपर से सब जा रहा है तो ऐसा बोलिए आप, we will make it more interactive. So this is the placement of the engine in the vehicle, because the placement is very much important, because ये आपने जो पहला जो फोटो देखा, ये क्या हो रहा है यहाँ पे अंदर आपको मालूम है कि केमिकल एनर्जी इज गेटिंग कन्वर्टेड इनटू मैकेनिकल एनर्जी. सो ये जो मैकेनिकल एनर्जी में जा रहा है, ये आपका फ्रिक्शंस उसमें बहुत रहता है, व्हीकल इज हैविंग मोर फ्रिक्शंस, और वो लॉसेस में कन्वर्ट होता है. तो वो फ्रिक्शंस हमको एनर्जी को अगर वैसा का वैसा निकाल के यूज कर दिया तो समझ लो 10 का एवरेज गाड़ी मिल रहा है, आपको 100 का मिलना चालू हो जाएगा, वो डिलाइटफुल हो जाएगा कस्टमर के लिए. बट ऐसा नहीं होता. तो मैकेनिकल में हैविंग इट इज ओन, यू नो द कार्नोट इंजन साइकिल ना, अभी भी आई थिंक कार्नोट ही है ना बेस्ट इंजन साइकिल. आप प्रोफेसर लोग आप बता सकते हैं मुझे उसके बाद में कुछ आएगा. व्हाट इज द एफिशिएंसी ऑफ दैट कार्नोट? बेस्ट एफिशिएंसी 100% वही है. दुनिया में कुछ भी 100% नहीं. मैं इन कॉलेज 16 to 18% हमने सुना था, तो उतना मैक्सिमम एफिशिएंसी था. आपको फॉर्मूला तो मालूम रहेगा, इंडिकेटेड मैडम ये ना फॉर्मूला तो मालूम रहेगा आपको, इंडिकेटेड पावर, थर्मल पावर. सो ये पूरा साइंस है इसके अंदर. आप ही लोगों का सब साइंस है जो जाता है और डेवलपमेंट के लिए अपने को डायरेक्शन मिल रहा है. सो दैट इज गेटिंग कन्वर्टेड. और उसके हिसाब से अगर ये ट्रांसफर पावर जो आपके क्रैंकशाफ्ट में घूमना चालू हुआ और उसको आपको गाड़ी के चक्के में पहुंचाना है टायर पे, तो पास में रहेगा तो कम लॉसेस होगा इंस्टेड ऑफ पुटिंग द रियर साइड. और ये बट इट डिपेंड्स अगेन द व्हीकल कंस्ट्रक्शन, उसका लोड कितना हैवी है क्या छोटा है, ये समझाना है मुझे. लेकिन कोई एक कैप्सूल सॉल्यूशन नहीं रहेगा, आपको डिसीजंस लेना है इसके लिए. सो दिस इज द प्लेसमेंट. दिस आर द डिफरेंट एप्लीकेशंस लाइक ऑटोमोबाइल इंजन. ये जो IC engine, it is being used in automobile, aircraft, motorcycle, marine propulsion applications are there. Non-road engines, railway locomotive. Basically, non-road and railway locomotive is more of a external combustion engines. Spacecraft propulsions and traction engines are there. This video is in details. It is showing what is the suction stroke, what is the compression stroke, then the power stroke, and the exhaust stroke. So till that you must be knowing the important parts of the engine. These are the different structures of the engine. Like some 4-cylinder engines are there, inline engine, V engines are there, opposed cylinder engine. All the BMWs are having V type of structure. I'm telling you. अपना जो इंडियन मार्केट वाला व्हीकल है उसका 4-cylinder inline engine ही ज्यादा रहता है. Some opposed type of engine भी रहता है. Opposed type engine is having a maximum efficiency, if you know, but it is having a problem of a placement. The area requires more. Now the valve opening and closing, अब कैसा होता है? It is being driven by one camshaft. Camshaft में valve रहता है, वो camshaft is being driven by again the engine only. उसका आपको rotation आपको मालूम रहेगा. This is an important part of the engine valve. सबसे हॉटेस्ट ऑब्जेक्ट ऑफ द इंजन जो होता है वो इसके टिप पे रहता है, वॉल का टिप जहाँ पे स्पोर्ट होता है ना जो मेन, उसका टिप इम्पोर्टेंट है. हॉटेस्ट ऑब्जेक्ट. दिस इज अ टाइमिंग चेन सर्कुलेशन के लिए. एंड हाउ वी आर गिविंग दैट स्पार्क टू जनरेट, दैट इज डिपेंड ऑन द स्पार्क एंड कंप्रेशन इग्निशन टाइप है. आपको ये मालूम रहेगा स्पार्क इग्निशन इज बीइंग यूज्ड इन पेट्रोल इंजन्स, गैसोलीन इंजन्स, एंड डीजल इंजन इज हैविंग अ कंप्रेशन इग्निशन. It is having a more compression ratio. We are compressing air to the extent, तो उसका ज़्यादा रहता है, 18 से ऊपर रहता है. उतना compression में आपने फ्यूल छोड़ दिया, इंजेक्ट किया स्पार्कल में, अपने आप ही सेल्फ इग्नाइट हो जाता है. Then the next category is the cooling of the engine. So many engines are smaller engines, basically low power engines are air cooled, and the higher capacity engines are the water cooled engines. So it is having it is own internal flow structure. This is the piston, internal view of the piston, how it look like. It is a crankshaft. It is the main, you can say it is the stomach of the engine, which is creating energy and storing it to the flywheel, which is the lever of the engine. Then the bearings are the critical parts. Valves are also different, like some engines are having 2 valves, some engines are having 4 valves. Latest different constructions are coming. It is only to create a proper turbulence inside the chambers to make it more proper combustion. Means CO2 NOx कम से कम generate होना चाहिए. For that reason, the structure is like this. Then again, we have discussed this. These are the main subsystems. We will discuss in detail. So coming back to the materials again, the cylinder block. We already discussed that the nodular cast iron structure is being used. So if you see something is written over there, मैं छोटा सा लिखा है. Sorry for this. आपको दिख नहीं रहा होगा. Basically, cast steels are being used. Cast irons are being used, which is having a percentage of 2 to 3%.
And if any deviation is there, we have to justify that deviation. All of them knows that corrosion is the big problem in the industry, and the same is happening in cooling tower also. Always that water is in contact with the metal. That's why we have to select factor of safety, corrosion allowance, and painting as being considered by designer. These 4 parameters are very important for cooling tower design. We'll go with the types of cooling towers. Based on shell profile and working profile, 2 types are there. One is NDCT and IDCT. Hyperbolic tower structures are there for NDCT, which is creating natural draft in the cooling tower. Another is IDCT, which is induced draft cooling tower, which requires fan to create the draft so that water and air contact will be there and the cooling purpose will be solved. Second is based on material of construction. Earlier wooden cooling towers were used. Then later on the development, as the development progressed, then RCC cooling towers came in the picture, and now the FRP cooling towers are in the picture. The subsequent, what are the development arising in the industry, it is going like and followed by everyone. Third is based on air and water flow arrangement. Counter flow cooling tower. In that counter flow cooling towers, air and water interaction is parallel. In cross flow, water is driving gravitally in vertical direction and air is passing in the horizontal direction. This is called cross flow cooling tower. For this heat exchange method, how this is happening? Air and water mixture is there. It is called wet cooling tower. When the coolant is inside the tube, it is called dry air cooling tower. Only air is driving the heat transfer. It is closed inside the tube. There is no direct mixing of the 2 components like air and water in case of wet cooling tower. For this, based on use, whether the application HVAC industrial, just I told about that, small cooling towers are used in HVAC industrial applications. But in other type is thermal and nuclear power plants. These are big cooling towers which are near about 120 meter dia and height is 180 meter. You just imagine one football ground is there likewise. And inside you cannot go due to this 100% humid environment. That's why so much precautions will be taken care while operating that cooling tower also. Based on inlet water, whether it is clarified pure water, and second one is now it is used everywhere as seawater. With the scarcity of water everywhere, seawater is directly used for the cooling tower purpose. But according to the seawater, we have to take precautions like corrosions and any other problems we are facing in nearby area. That type of problems again we have to face. But to manage the cycle and availability of the material, we have to choose whether it's a purified cooling tower or seawater cooling tower. If abundant quantity of water is available, then no problem. We are using purified cooling water after water treatment. This is the best choice. If water is not there, it is near the coastal area, then seawater is used. What is the precaution? We will see in the next slide. These are the pictorial view of the Indy city, and that is the ID city. This is the internal of cooling towers. What is the inside the cooling tower? Inside cooling tower, both the cooling towers have only one difference, that air circulation is caused this by natural process, and second is caused by the mechanical process, that is fan is used for the circulation of the air. That's why it's induced draught. The rest, I will start from one by one. First, the hot water is coming in the distribution pipe. It is sprinkled by nozzles above the fill area. This horizontal is fill area. This is close to the tower. This is the fill area. It is the medium used for the increasing the heat transfer rate. We will see that fill, types of fill. Then is the rain zone. Water is gravitationally come down in the basin. Same here in IDCT. Only thing, at the upper part there is a fan installed, fan assembly, and fan hub, and then above that, below that, gearbox, the drive shaft and motor. This additional mechanical assembly is required in the IDCT. I will cover the 6 atoms here. These are major atoms. We should aware about these atoms in the cooling tower industry. One is fields depleter, weld mesh. Then I will cover PP nose, nozzles, grid. For this fan drive shaft, which is required for IDCT. Then water distribution pipes. What are the different types of distribution system we will discuss. And then last FRP items we will discuss. This is the Cooling Tower Technology Institute. This institute develops some standard specifications in all over the world that are going to followed by everyone in the industry. They develop regularly some revisions in the materials. What are the technologies, technological improvement is there. They add that specification in their standards and they publish that standards for the all industry, vendors, colleges, everyone that will be followed. This is the prime institute, and in the worldwide only this institute is there, which are going to develop their standards. Likewise, this is a non-profit self-governing technical association. Its purpose is to advocate, promote the use of all environment responsible commercial cooling technologies, form information exchange, to dialogue on the benefits of different cooling technologies. They conduct some seminars also to understand the development in the industry. Second one, they publish, they conduct exhibitions, they publish some monthly papers so that everyone should be aware about the environment. And we are the member of that CTI. In most of the technical requirements in cooling towers, these are very common to avoid the corrosions. Now SS304, then later on SS316 material is in picture. Then now duplex SS material is everywhere used in the cooling tower. Because of their property. Earlier, the specification is for the given shall be hot dip galvanized MS pipe. MS galvanized, that should be as per IS 2629, IS 4759, and another is zinc coating will be there, which is again upgraded for 610 grams per square meter. Then again requirement is coming 950. Then it is showing that we should avoid the corrosion as much as possible. The fill material is basically made of PVC, polyvinyl chloride. It is a very cost effective, that's why it is used in the industry. It's very durable, its life is 15 to 20 years. It is resistant to corrosion, especially withstand the harsh environment including exposure to UV light, water, chemicals. Here the properties are very important while using the cooling towers. We are seeing PVC everywhere, but for cooling towers it especially should be as per the cooling tower institute, which is designed by standard specifications. The PVC material is mostly 90% is used in the cooling towers. Apart from that, these two materials are used, that is precast concrete laths and wooden laths. In fill there are two types. One is fill fill and second is splash fill. In fill fill, the film is created by water flow and air and water contact is become like a film. That's why it is called film fill. The second is splash fill. In splash fill, one we'll say the stagger pattern is there, and when drop is falling on that field, it is again splitted in different drops, so that its size is minimizing when it's come down. And as soon as that sizes of droplets come down, the heat transfer rate will increase. This is the phenomena behind this splash fill. One thing is that this splash fill is not clogging because of the dirty water, impurities in the water. And fill fill, if you have to take care about the quality of water. Only that 19 mm fluid is there, so that heat transfer will be there. This is the specification and the logo of CTI. They have given this specification in CTI STD 136. There are other specifications also, but the field is covered in this area. CTI STD 136. In cooling tower, heat deflection temperature, UV resistance, impact resistance and flammability are the most important properties which are to be taken care. This is the module prepared after joining the field sheet. First of all, one sheet is there, then it is compressed in making the flute of that size, corrugated flute. Then at side it is corrugated. It means that we have to join the two sheets by glue system. Cyclohexanone is used for this gluing purposes at side. They are prepared in the module, and that module is placed inside the cooling tower. These are in various different sizes as per the requirement of the column and beams, so that layers of that film module will be prepared at site. General technical requirement in the field is that it should be large, specific surface should be there, so that air and water contact will be more. Low falling fields, it means that there should not be clogging every time. It should be easy to clean and it should be lightweight. That's why this PVC material is used mostly. While purchasing this field, we need the raw material specification. In that, it is seen that PVC resin is used, mainly supplied by Reliance, Formasa, and we required to pass this material with the help of material test certificates. Because this is the one genuine document which is required to correlate whether we are purchasing this material with the right company and with the right specifications. Because there are companies which are the approved companies. So that material test certificate is very, very important for the construction. Cyclohexanone is used to join the film sheet. These two properties are very important to be checked in the printer. In other parameters are also there. I have covered these parameters only to understand regarding these properties. One is flammability. It should be fire retardant. That fire should be stopped when it is just ignite within. If we take that material and place in the outside sun, that UV resistance should be as per these standards. Whether it is like before UV test and after UV test, the test is done. Isolation impact test is done before and after, so that if the material parameters are meeting, then we accept that material. These are the UV resistant tests. These are the specifications which are generally provided by the client. You have to confirm that specification, whether the material is as per the specification or not. If any deviation is there, we have to comply that by mostly rejecting and rectifying that product. Here that we have mentioned the flute size, that will be at 19-20 mm. Flute size is nothing but the hollow space inside the film module. Thickness is 0.25 mm. It is given the tolerance 0.02 mm. It is very important because if we reduce that thickness, their strength will be reduced and it will deteriorate within 10 years. Most of the manufacturers make below 0.25. That will be very difficult for one construction company to take that material. Color is different, that is specified light, grey, white. It is depend on the specifications. Maximum temperature PVC handling is 55 degree centigrade. Type test of PVC material. This point is the exposure for 500 hours. These 500 hours are taken at the third party. In that, UV rays are taken, and these are for the film. One film is there, and that you have to conduct both tests, isolation impact test before and after 500 hours. And in that, if the property is there matching, then this third party laboratory like CPET, Chennai, then Sriram Lab, New Delhi, they release the certificate that your material is conforming to the CTR standard. It is within the limit. To achieve this performance in the print hours, special additives are developed by raw material matrix to get the desired material property by manufacturers, which leads to the improvement in the characteristics of the film. This includes stabilizer, high temperature additives, flame retardant additives, antimicrobial additives, and UV stabilizers. This is one checklist. These are the parameters: density, tensile strength, elastic, texture, tensile, isolation impact test, liquid softening, heat distortion, and fire retardant. I told about isolation impact test and fire retardant. Okay, that same is here, and the test method is given, value specified by the specification, and then value obtained after the inspection. These are, if it is within the limit, then we accept that material. This is PVC rebar. This is in splash film printers. Same properties are there which are used for the film because the material, raw material is same, PVC material. Only thing, the size and its application is changed here. That is used in the film, this is used in splash film. But the raw material testing will be the same everywhere. The same parameters will be tested at vendor's factory. These are the drip printer. Drip printer is used to all the exhaust air coming from the cooling tower. It is exhausted in the environment, so that we have to minimize and reduce that water droplets to come outside of the cooling tower. These drip printer are placed over the water distribution system. I will go back one slide. These are the drip headers, upper, at the upper side. And then water distribution system starts. The drip headers can be of blade and cellular type. Blade profile is like the C profile, and 1 meter, 2 meters is the length specified as per the drawing, and cellular is it is, as we have seen in the picture, it is formed in the module. That's why it is called cellular type drip headers. Function is the same. Only thing, these are used in some different application. This blade profile is very easier for the installation purpose. Here, since the material is PVC, same testing is done for this. Only thing, this profile is different. Same life is 20 years. Dip loss depends on the tower configuration, illuminator design, airflow rate through the cooling tower, and water loading. Various designs of drip headers are available in the market. This drip contains most of the minerals of the makeup water and often contains water treatment chemicals. Contact of these chemicals with plants, building surface, and human activities can be hazardous. It is forbidden to walk and stand on them, because this is a very important item in the cooling tower. If it is that profile is that spacing is disturbed and that profile is something you can say damaged, then water droplets may come outside of the cooling tower. We are paying with the contractor. We are getting the material from the vendor. Then we have to must check his quality. That quality should be there. That the same quality is quality plan is called manufacturer quality plan. That manufacturer quality plan is specially designed for the vendor where it is manufactured. Okay, that is the quality guarantee given by the manufacturer. That is called manufacturing quality plan. And then if the material is purchased by your end, then as a contractor, that same material after erection, you have to check that material with the another quality plan, that is called field or erection quality plan. So that whatever the design parameters are there, that should be achieved by raw material and erection of the site person. That's why the two quality plans are there. One is manufacturing quality plan, one is field erection quality plan. Second item is SS weld mesh. This mesh is made of SS304, SS316, and nowadays it is asked for the duplex SS. The mesh sizes is 100 by 100, 200 by 10, depending on the design of the parameters. In that small triangles, these are the fields, splash fields, what we have seen earlier in the slide. They are put in the staggered manner, one by one, and splashing of water is taken place in this mesh and V-bar. This is the installation at site. Wire size used in the mesh is 3 mm dia vertical and 2.5 mm dia horizontal. For this height of this mesh is 2.4 to 4.5 meter height. Duplex SS nut and bolts are used everywhere for installing this mesh. Another one is nylon cable tie. that our SWG SS316 binding wire are used to glue or to mount this V-bar in the mesh. This is the SWG sizes available in the market. Many times it is specified in the SWG sizes. We should know about what are the conversion factor in mm. For 10 SWG it is a 3.25 mm available in the market. While placing an order, we should aware about all these conversion factors so that we will get the exact material. Otherwise vendor may confuse and he will quote another different material for us, and which will again we are not able to compare the material if we are that same size is not offered by another vendor. The main difference is SS304 and SS316, that 18 and 8% nickel, whereas SS316 contains 16% chromium, 10% nickel and 2% molybdenum. 2% molybdenum is the facility given in the SS316 for the corrosion resistance. While purchasing this material in types of rod, sheets, we need the material test report. Either it is manufactured by original manufacturer, that test certificate shall be complied. In the table it is very easily shown that comparison, the chromium nickel percent is there and 2% molybdenum in 316, and L is showing that the carbon percentage variation. Always these four parameters everywhere is used in the industry. 304, 316 means it's a regular ordering of this sizes. Another sizes is there, grade is there, 202, 416, likewise. But these the most popular grades available in the market and used by the industry. Duplex SS has the characteristics that microstructure of duplex includes both austenite and ferrinite. It is a 50-50%, which will give these steels their unique characteristics like mechanical corrosion resistant properties. Duplex stainless steels are highly alloyed. The cost of using these materials is high. Recently, duplex SS requirement increased over other SS grades due to its high strength corrosion resistant properties. The grades available in the duplex are alloys 2304, 2205 and another is 2507. This is called super duplex SS in the market. See, these are very costly. Earlier only MS pipe are used everywhere and they are called for the optic galvanized. That it is very cheaper. Nowadays this means 4 times that material cost is increased by this duplex SS. Third item is nozzles, grids and grid. These are made by polypropylene material. These are injection molded. And the raw material used was PP0133 or Repos H110 MA of Reliance. Reliance is used only that it is a means 99 market is covered by Reliance. Size as per the design. These are the nozzles which sprinkles the water above the fill area. These are the grid 100 by 1000 by 750 mm. This is the size given in the grid. And another photo is of the trickle grid. This shows the difference. This gives the difference. Film and flash film, trickle grid. This is the combination of both the types, film as well as flash film. This third item, I will cover again that also. Trickle grid, that's why it's called trickle grid. It is the combination of the film and flash film made up of polypropylene due to its non-clogging tendency, light in weight, easy to install, high surface contact, fluid size is 20 to 25 mm, life of service 15 years. It is same the properties UV resistance, fire retardant, less powdering characteristics. Means this fill is covering all everything that is the requirement of the industry cooling tower. Means you are getting the benefit of fill field as well as flash fields. Its installation is also very easy. In earlier field, I have seen that for gluing cyclohexanone is used, but here is the mechanical assembly. Only that push type of button is there. One by one modules are prepared. Means no need of any cyclohexanone, which is a chemical, which is hazardous chemical actually. That is not required in this case. Trickles field. This is normal difference PP and PVC. Because yesterday you visited the factory, na? Correct. In that PVC, PP, these are very common material. These are the difference given in the slides. Main is that PVC is denser than PP. PP is injection molded. Mostly toys are used in the PP. PVC is extruded in the form of pipe, in the form of different lengthwise. This longitudinal format you can easily manufacture by PVC. Flexibility, PP is more flexible than PVC. Temperature resistant, chemical resistant, both are in the quality. Density, PVC is denser. Cost, PP is generally more affordable than PVC, making it a cost-effective choice for many applications. Main important assembly in the IDCT is this fan assembly, where it contains fan blades, fan hub, and hub boss. It is called hub boss. I will explain that. Fan impellers are fully balanced, specially manufactured to suit the cooling tower application. Impeller blades are made up of FRP. Fan impeller assembly consists of hub, holding clamps, impeller blades. The hub is made up of MS, which is zinc sprayed galvanized to prevent oxidation and corrosion. Blade rests are aluminum alloys, which is basically to reduce that weight and to avoid the corrosion. Blades are made of FRP. These are the standard IS 1963. These fan blades are made by hand molded hollow blades. One die is there, and all the FRP raw material like mats, they are placed and glued by hand, and these are kept in the die for certain hours, and then that fan is ready, fan blades are ready. These steel flange and MS plates, which are highly galvanized, and then it is bored as per the gearbox output shaft, because it is mounted on that gearbox output shaft. Why it is used? FRP axial fans, and this material is used in the industry. It is given that advantage. Fan impellers are aerodynamically designed. Therefore, they provide higher efficiency in the cooling towers. Higher efficiency of fan blades is given higher rate of delivery of air. High rate means air and water contacts will be more. That's why you will get the higher efficiency of cooling tower. Reduction in overall weight of the fan. Earlier, aluminum blades were used. They are heavier than this FRP. That's why the weight factor is very important while selecting the fan blades. Requires lower drive. Obviously, if weight is reduced, the power will be required reduced. Light duty bearings, bearing system will be very easy to design. These are fabricated by compression molding techniques, which would have uniform dimension, consistent quality, lower flow noise, mechanical noise level compared to the other conventional metallic fans, aluminum. Longer life of fans. Other properties are the same, like weather resistance, heat resistant, corrosion resistant, moisture resistant, abrasion resistant. Dry shaft, earlier the dry shaft and coupling, which is joining gearbox and motor, which is called dry shaft. Dry shaft earlier is made of SS304, SS316 material, and this is again having flexible coupling which transmit some vibration or misalignment available in the system. That's why this is called the flexible coupling. one available dry shaft nowadays, it is a carbon fiber dry shaft. This is made of modulus carbon fiber and reinforced plastic to create special tubes capable of handling. Same material, same sizes will be there. Only material of construction is fiber composite material is used in the dry shaft. Here one facility is that in dry shaft you have the flexible coupling inbuilt with that shaft. In another SS304 metallic shaft, separate coupling is there. Next slide I will explain that benefits, advantage of steel and composite shaft. Weight in steel shafts, it is very heavier. Composite shaft, ultra light, 15 to 25 kg only. One man can easily carry that dry shaft to the side. But for this steel shaft, we need crane, then install at site. It is very difficult task and need skill for that. But here, composite shaft is very easy to assemble. Vibration, higher steel shaft. Then here in composite shaft, very minimum vibrations will be created. Corrosion in steel shaft, high. In composite shaft, no corrosions will be there. Service life 5 to 7 years. Here it is up to the cooling tower life is there. Flexible joint, same pin and push, but here is the only one piece is there in composite shaft, so that it will not create large vibration in the system. Downtime higher, obviously if vibration is there, you have to take more maintenance in that steel shaft. Hot water distribution system. This water distribution system inside the cooling tower is very much important because even water supply at full the periphery of the cooling tower is very important, because same principle, air and water should be mixed each other in each area of the cooling tower. There should not be wide spacing in the cooling tower. Three materials massively used in this water distribution system, which are AC pipe, UPVC pipe and GRP pipe. AC is asbestos cement pipe. Second is UPVC pipe, unplasticized PVC pipe, and third is GRP pipe. These are used in the industry. The choice is depend on the specification given by the. If it is not given in the specification, then designer has to choose the material. While choosing the material, he has the choice whether I have to use AC or UPVC or GRP. Obviously, designer will consider first factor is weight, second handling of the item, whether how much is the span required for handling. Then third one is the price. This is very important, I guess. The header pipe, before distributing inside the cooling tower, the header pipe is there. Header pipe is the main branch which is coming from the condenser. That pipeline is there. That is mostly made up of MS pipe. MS pipe is having IS3589, which is made up of FE330 or FE400 grade. FE400 grade is nowadays mostly asked by the client. This IS3589 is used mostly for the above 150 dia pipe. Coating and painting, these are the different specifications apart from this material of construction. If we have given only material of construction for MS piping, then painting and coating is very important to avoid the corrosion for the piping. Now that internal distribution piping is of asbestos cement pipe, HDPE, PVC and GRP. HDPE is the option given by the client, but this is very difficult to install at site. Whether it's at ground level, it will be very easy for HDPE pipe, but for the AC pipe and other pipes, we can install it in the cooling tower at near about 13 to 14 meter height. AC pipe, these are the class 15 IS1592. It is heavier to handle. Difficult to join the fittings due to its weight. Nowadays, due to the hazards of asbestos, Their uses are limited. AC pipes are made of a mixture of asbestos paste and cement by steel rollers to form a finished product. These earlier are used in the most of the powers, public thermal power station AC pipe. Nowadays they are also removing this AC pipe because the asbestos is banned everywhere, and due to this hazardous properties, and it is available now that PVC is available in the market and very easy to handle, low rate, and second thing, easily available in the market. This UPVC pipe is of IS 4985. It is very familiar. You can say it is used for the agriculture purpose. Everywhere, most of this high standard is followed. 4985. In that, different classes are there: class 1, class 2, class 3. Depends on the what is the pressure required in the pipe. In the print tower, mostly plain-ended pipes are used because that couplings are easy, very easy to join at the site. In other purpose, in agriculture, we are seeing socket and pivot joints.
Definitely the career, as whenever we are saying that nation is under development and nation is growing, that nation, the growth of the nation is depend on us, because we are the only part. When we will grow, our organization will grow, our locality will grow, definitely our state will grow, and ultimate aim is to grow our beloved nation, India. So this is a contribution from the government side, and we should take the benefit of each and every initiative of the government, and that will be useful for the growth of our career also. So in concluding, I am very thankful to all, and definitely there is a test session. In that test, you have to attempt the questions, and you have to score the minimum 70 marks. There is no certificate distribution ceremony, because the certificates will be given by the AICTE ATAL directly to your login. Once we will fill the marks after the assessment of this question paper, you will get all the details. So, best of luck for your future endeavors. Thank you.